until we're ready to go. Now, first thing we're going to start with is the syllabus, and I don't have this is the other thing I meant to do before, and sorry about this. I thought I had gotten that done, but that's when the interruptions started. I can close this one out. And yuck. I hit the wrong thing. Let me see. I'll get there one of these days. All right. Whew. There we go. All right. Now, start off with my apologies again. Sorry. I was, if you hadn't already heard this, I was out of the country for the last 10 days or so, and we just got back late last evening, and so I tried to do while we were overseas. My wife said, don't bring your computer, probably have trouble getting it. She don't take her iPad. She had all the connections and things that she needed for that. So she said, you can use that. Well, we didn't have much time for me to use anything. But then when I did have time, she was using hers and she had priority. But when I did have time, I tried to update as many of my classes as possible. And I found out that nothing would update, okay? I could see the stuff, but it was either the fact that the iPod is an Apple product and everything was done in, Windows and IBM format and that type of thing. I could open the things, but I could not get the packages to do. I couldn't change anything. I could read them, but I couldn't change them. I could do some emails. I did a few emails, but that's the only thing I found. Now, the other thing is we have Lost and State webpage, and I was having to go through that, and that may have blocked me. I don't know what it was, but I couldn't get anything updated. And we got home last night, like I said, fairly late. And yesterday, we had to get up at 3:30 Edinburgh, Scotland time, which was 7 hours before this time. So that would have been about 8:30 the previous night on this time. And get to the airport, flew to Amsterdam, had a layover there, flew to Atlanta, had a layover there, and flew home, and then had stuff, and I had less than an hour's sleep total from that time until last night. So even if I had gotten on my computer, I probably would have screwed everything up. I was brain dead. So anyway, nothing of this is updated. I'll get it updated as soon as I can. Hopefully I have some office hours tomorrow to work on this, but as I tell you, the rest of my schedule and stuff, you'll see I don't have many office hours anytime. But anyway, it's the summer. This is summer 2018, not fall 2017. But the bulk of this is going to be correct. It's just the days and times are going to be different. The course is a 4-credit hour course. 3 of those credit hours are theory, in other words, lecture, class, that type of stuff. 1 credit hour is lab, but it says 5 contact hours here in a normal 16-week term. Since we're in a 10-week term, we're actually, the number of credit hours is the same, but we'll actually be in class each week about 4 hours, a little bit short of 4 hours, and we'll be in lab an hour and a half, technically an hour and a half a day for 2 days, so that'll be 3 hours that to give us the, it's supposed to be a 2-to-1 on a 16-week. In a 10-week, it becomes a 3-to-1 because everything's short. So our contact hours is really closer to, what's that, 4, 3, 6, closer to 7, pretty close to 7 contact hours a week. So the class meeting times are Tuesday, Thursday. We start, not today, but most days at 12. The class goes 12 to 1:50. There's close to 2 hours there. And that's here in this room. The laboratory will be Tuesday, Thursday. As soon as that's over with at 2 o'clock and go until 3:30. Okay? And most of those will be in this room. Yes? Oh, absolutely. Yeah. Most of the time it will be in this room, at least for the first several labs. When we get into the last part, we'll have one lab that will be in a computer lab. We'll have to find a computer lab and go to it. And another one will actually do a wet lab that we actually go to a place and do some an experiment where you're taking measurements. But most of the rest of the time will be in this classroom, even for the lab. Okay. Now, this part of it is correct. My name's correct. I'm still Charles Fowler. My office is here on this campus. My office here is in this building in room A265. Now, let me show you where that is, because I don't recognize most of you. Several of you I know I've seen before, but most of you haven't. Here we are in this classroom right here. Okay? And you go out into the hall, take a left, you go down half a flight of stairs here, and go almost to the end of the hall. Don't run into the wall, and don't go to the stairwell. Just before that stairwell is my office, A265, right across the hall from the orientation classroom, if any of you have done orientation here. Okay? Okay, so that's where my office is, 265. On the Birmingham campus, I have an office there too. It's not really mine. It's one I use on Fridays. It's in the academic building, which is also the B Hall, and it's in B122. Now, my name isn't on that door or anything. What you'll see there is Dr. Carl Pruitt, who is the Associate Dean for Liberal Arts and Transfer Programs, and Ms. Rose Saxon, the Secretary, Administrative Assistant. Now, I'm only there on Fridays, which means tomorrow and next Friday. But then all the rest of the Fridays in June and July, the campus is closed. We go to a 4-day work week for the June and July, Monday through Thursday, averaging about 10 hours a day. And I'll be here longer than that, all 4 days, but that's beside the point. And but when I am there, that's where I'll be. Okay? Now you can call by phone at 929-3449. That's my phone number here on this campus. But when I'm on the Birmingham campus, which will be this Friday, next Friday, and the first Friday or two in August, I can't remember how many Fridays are here in August, I think it's only one. This is my number at that office, 929-6409. Now, here's a little bit of a problem. My voicemail here is unreliable. I don't know why. I think the box got too full. I don't know if you can even leave a message, but if you do, sometimes I can't hear it. It's just messed up, and I don't know when I'm going to straighten it out. But so basically, only call during my office hours. But as you are going to see in just a minute, I don't have many office hours, so it's a big problem. Now, on the Birmingham campus, this is my phone number, but please don't leave a voicemail there either, because that's not my telephone. That office I use on Fridays is normally the grant coordinator office, and she's part-time, and she's only there Monday through Thursday, so I use her office on Friday. So if you leave a message, it goes to her voicemail, and I never hear it. I can't access her voicemail. So basically, only leaving voicemails here during my office hours. No, only call during my office hours. Don't bother leaving a voicemail. If I'm in the office, then we'll talk. If I'm not, try again later in office hours. Here, don't ever leave me a message. But there, I'm more likely to be in the office than I am here. My email address is cfowler@bostonstate.edu. And by the way, all employees of the college, the vast majority of us, first initial, last name at bostonstate.edu. So you know just about everybody's email address who works for the college. That's not students, but working for the college. There are, of course, a few exceptions. We have more than one S. Williams. You might guess that. S is a very popular first initial, and Williams is a very popular last name. So for some of those, it's two initials, last name at bostonstate.edu. There's a few people, I only know of one right now, who have special ones, like Mr. Calvin King, who teaches speech and English. He decided to be, rather than K. King, Calvin underline King. You know, the dash in between is the underline. So he's Calvin King at lawsonstate.edu. But most of us first initial, last name. Now, these office hours are totally wrong. These are for last, what was it, spring or fall, whenever it was. I worked on this while I was overseas, and then in packing and stuff, this piece of paper got crumbled. Right now, my office hours are Monday, Wednesday. 8 o'clock, I've got Calculus 1. It's a 4-hour course. Since we're in 10 weeks, that goes for 2 hours and 40 minutes a day, Monday and Wednesday. So it goes from, I'm usually here by 7:45, and you'll see this on my locator card later. But I'm usually here by 7:45, but I only got 15 minutes in the office then. Then I'm in class from 8 till 11:40, and then my next class starts at 12. So I've got 20 minutes office hours between 11:40 and 12, and, 10:40 and 11. It's 8 to 10:40, and then I have from 10:40 until 11, so that's 20 minutes in my office. And then my Cal 2 class starts at 11 and goes to 1:40. So I have another 20 minutes there between 1:40 and 2. Now, right now I'm scheduled for Physics 202, 2 o'clock on Monday, Wednesday afternoon. But the last time I looked, and that was this morning, it didn't have 10 students in it. Now, we're not going to cancel the class, but if we don't get up to 10 students, we'll probably stack that class with Physics 214. It's the same physics, it's electricity and magnetism, it's just that the level of math complexity is different, but we use books by the same authors, so they have the same pretty much PowerPoint and everything else, so we'll probably wind up stacking those two classes. If we do that, then I will have office hours from 2 until 5:30, and that will be my biggest and almost only set of office hours, from 2 until 5:30. Now, if up to 10 people register for it today, and they're still having registration as far as I know, and they get up to 10, then I won't have that time off. But then, beginning at 5:30, I have my 201 class, which does have more than 10 students in it, so I'll be here from 5:30 until 9 o'clock, okay? So, long days on Mondays and Wednesdays. But I may have some office hours in there. Now, Tuesday and Thursday, again, I'm here at 7:45, or I try to be most mornings. But then I have a differential equation class that goes from 8 to 10:50. And before this morning, I only had like 3 people in my linear algebra class, so I thought that one was going to be canceled, and that was going to be a set of office hours. Well, this morning, when I printed off the rolls, 6 people. So I don't know if they're going to let it run to 6 or not. We'll find that out. So I may have from 10 till 12 open office hours, or I may not. I just won't know until we had class this morning. Then this class starts at 12. Normally I'd have 10 minutes between each of those 2 classes. And this starts at 12 and goes to 1:50. Then the lab goes from 2 until 3:30. Then I have 30 minutes of office hours. It looks like, but really I'm traveling to the Birmingham campus. So I'll leave right after our lab's over with, head to the Birmingham campus, and I've got a physics class there from 4 to 5:30. And then how much longer I'll stay, I don't know. Since I'm here till 9 o'clock on Monday, Wednesday, I don't think I'll be on campus much past 5:30 on Tuesday and Thursday. So if all the classes make, I have 20 minutes, 20 minutes, 10 minutes, okay, on Mondays and Wednesdays. And 10 minutes, 10 minutes, and that's it on Tuesday and Thursday. But there's a real good chance that one of those 2 classes, and maybe both of them, will be canceled, or stacked, or whatever. So you see, I'm not in the office very much this summer, except maybe if one of those 2 classes gets canceled. So there's office hours. Once I know for sure, I'll update the syllabus and get it out there on Blackboard. It's not there yet, so don't even bother looking for it. But as soon as I get it, I'll let you know. Okay, the course description. This course, and by the way, I didn't write this. No one else here at the school wrote it. This was something determined by a committee from the two-year college system and the state-supported four-year college and university here in Alabama. And they agreed to give you credit for this if we beat this. This course provides a non-technical student with an introduction to the basic principles of geology, oceanography, meteorology, and astronomy. Laboratory is required. Now, we couldn't change this, okay? And really wouldn't want to, except for the order, okay? We'll talk about that in just a few minutes. But remember, geology, oceanography, meteorology, and astronomy. Okay, prerequisites? None. There is a little bit of math required in the course, but basically if you've had Math 098, you've got all the math you need. If you don't have 098, you probably still know enough math to get it done. Okay, if you started at something higher than 098, you're fine. The book is Tillery. Now, has anyone purchased the book yet? Justin, did you have the big book last term, or did you have a little one? Okay, so is that your 111 or 112? That's from this one. Okay, if you don't mind, yeah. Now, these two books look the same except for the thickness, obviously, right? This company does what they call customized text. And basically they say, if I give them the chapters I'm going to be using, because I'm not going to use this whole book, not for this course anyway, that they'll customize and just put the chapters I am using. And that saves you money. Okay? And if you do take Physical Science 112, I don't use all the rest of the chapters, so that still should save you money. Okay? If you do take the other. Last term, they didn't have all these in yet, so a lot of students wound up with the big book. If you can find the big book, find it cheaper than the little book in the bookstore, find someone who had it last term and wants to sell it or loan it to you, you can do that. Okay? Now imagine they got ebooks, I don't know, you can rent books, but this is the text. Okay? And as I was going to do when I picked it up was Bill Tillery is the author, Physical Science, 11th edition, that's the edition. It's a McGraw-Hill book, 2017 copyright, and it says students are expected to bring your textbooks, paper, and a pencil to class each meeting. Calculators are permitted for the course. You won't really need them that much, but some of the labs you do have some minor calculations to do. Always there's a few additions and subtractions and things like that, so if you like to use a calculator for that, certainly fine. Simple, a freebie calculator, it just says addition, subtraction, multiplication, division will probably get you through the course okay. Scientific calculator certainly would be all you would need. You may not need that much. Okay? I'm trying to think. Like I said, the labs have some operations to do, mostly division, multiplication, subtraction, that kind of stuff. The tests, I don't recall any of the test questions that really require much calculation at all. It's either something you can either do in your head or just the principle of it. So you can get by with minimal calculating skills, okay? This next paragraph is one they do not let us change, and it drives me crazy because it's out of date, but they say you can't touch this paragraph. All of us as a community college students must be trained in Blackboard and use Blackboard daily to gain access to vital course information such as the syllabus, and you will be reading the syllabus every day, won't you? Saturdays and Sundays included. Every day. Yeah, of course you will. I'm making fun of it. Sorry. Okay, handouts. Now, most of the time, if I have a handout, guess what? I will hand it out to you. So I don't usually put handouts out there either. PowerPoint shows they will be there. Okay? I don't have them there yet because, like I said, I was out of country and could not get the things back onto Blackboard. Okay? So they're not there yet. I've got some office hours tomorrow, but I don't know how much I'm going to be taking up with meetings or schedules or other things like this. I know at some point we've got to cancel a bunch of classes, And when I cancel classes, I like to call students to let them know they're being canceled, and it could eat up my whole Friday tomorrow. I don't know, but if not, I'm going to try to get those things in Friday or sometime over the weekend. Okay, or if I wind up with some time on Monday, I'll maybe get it done there. Activities. Now, sometimes the school posts activities out there, and if so, you can do those. Follow those on Blackboard. Assignments. I will be putting the research paper assignment out there. It's not out there yet, but I will do it. Justin shaking his head. He remembers that fondly, don't you? Yes, I thought you did. Okay? Now you did a good paper last time. And then the other things will technically be on Blackboard, but you have to go from Blackboard through YouTube to listen to the recordings. And on the recordings, I make the assignments. So I don't type them out and say, this is your assignment for this day. You have to pick them up on YouTube. Okay, but that's through Blackboard. All right. Announcements, and again, most of the time these are going to come from the college. Okay? You're here for class, right? Okay. We had a student come in this morning who came to make up a bunch of tests. And I've got to find, here's the roll. Okay. This way to go class. Still go by Lauren. Yes. And we have everybody but Adam Christopher Lee. Does anyone know Adam Christopher Lee? Okay. 11 out of 12 people here. Love to see it. It'd be better if there were 12 out of 12, but love to see good attendance. And frankly, last spring's Physical Science 2 class, it was almost as well attended every time too. So y'all are good. Okay. So announcements. Most of the time those are going to come from the school. I will have some announcements that I may be posting, and I know there's probably going to be one right now, or at least there's a chance of it. And let me explain what that one is, and this is really bizarre. And like I said, I've had 10 minutes between classes, and every 10 minutes between classes has been filled with something. I got to my office just the time it took me to exchange books. Okay? That's the only time I've been in the office since I came in early this morning. And I printed off the rolls there. This is from my doctor's office. Not that y'all really care that much, I guess. But this is when I was scheduled for an appointment. I don't know if you really need to know this, but I'll go on and tell you. I have a mild form of leukemia. So I have to do treatments about every month, sometimes every 2 months, something like that. It's really mild stuff, and it looks like this new set of treatment is knocking it out. I'm hoping it's going to be over soon, okay? The disease, not me, but yeah. So I see a hematologist, but he only sees patients on Tuesday mornings. And the last time I was in there, and they didn't put a date on this, but they told me and printed it off here, my next appointment, it said, was Tuesday, June 5th at 11:40. Okay? Well, that's not this coming Tuesday, the following Tuesday. But when we got home from the airport last night, we had like 7 messages, and I listened to them, and the thing from UAB said, this is the message for Charles, reminding you have an appointment on Tuesday at 11:40, blah, 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 blah. I said, now wait a minute, I thought it was in June, but maybe. So I don't know. They didn't say June, this coming Tuesday. They usually don't do more than a week ahead of time. So I don't know what they meant. And so when I found this morning, I said, nope, this was Tuesday, June 5th. So I was going to call them, but I had to wait till I was here on campus because they're not open before. And my 10 minutes in between classes have been eaten up by everything else. I haven't found out. So hopefully I won't have time today. Tomorrow, when in my office hours, I'll find out when this is. If it turns out that they moved my appointment from Tuesday, June 5th to this coming Tuesday, then what that means for y'all is, okay, get this. This appointment is 11:40, but I have to be at the clinic for at 10:40 for blood work. So my 10 o'clock class is wiped out because I have to leave here around 10 to get there at 10:40. Okay, so my 10 o'clock class, if it's going to meet, is going to be wiped out completely. This class, however, if the appointment's 11:40, hardly any way it's going to be through before 12. If he really gets on board, this is the last appointment he has in the morning, and if he's gotten behind, then it could be, I'm not going to be here at 12 o'clock. Whatever Tuesday this appointment is, whether it's this coming Tuesday or the next one. I hope it'll be over by 12. 12:40 would be about the time it takes me to get back here. So I would say 12:45-ish. But if you could be here at 12:30 and wait, I'll get here as soon as I can. Yes? What's that? Okay, but you want me to find time in the day to do about this will be an hour, 2 hours, close to 3 hours to record. I don't have 3 hours in the week anytime, unless one of these classes gets canceled, that I would have to do that. So I'd rather be here because we're going the bulk of the class, and we'll probably have a lab, and I can't really record the lab. So we need to be here, and it's only going to be a 30-minute to 45-minute later for y'all, so I could record that much, but I don't think that would make a lot of sense either. But let's just plan to delay the class. But I don't know which day it is until I find out whether they're talking about next Tuesday or this coming Tuesday. So I'll find that out. If I find out it's this coming Tuesday, I'll put an announcement on Blackboard that I'll be at the doctor's office until about 12, and it'll take me another 30 to 45 minutes to get to campus. So let's plan to meet at 12:30 or 12:45. Okay? If I find out it is June 5th, then we'll have lots of time to get that information out to you. So if you don't see anything, be here at 12 o'clock on Tuesday. If you do see something, then you know to come a little later. Or you can come at 12 and study. I know you want to do that, yeah. Okay. But I will be here, and it's not going to be a big delay, but just a little bit of delay. But that's one place where I would make an announcement, okay? Anything else that comes up like that, we'll do too. Now, this class does have two potential field trips. When we get to the end of the astronomy section, I usually try to schedule a field trip to the Samford Planetarium, and we'll go and see, and he gives a really great presentation. Now, last summer, he was booked almost solid, and the only time that would fit in this class schedule and his schedule, we were in there with a bunch of elementary-age kids. They were sort of loud, but it was a fun presentation, but it was a little loud. And if we find out it's going to be like that and y'all would rather not do it, we don't have to do that. But that's one field trip. The other one is really late in the term, is when we do the meteorology chapter, the Earth's weather, weather and climate is the name of the chapter. Usually the lab for that one is to go to Channel 13 Weather Center, and Jerry Tracy, or whoever's the weather person at that time of day, will host us and go into things about the weather. So those are two potential field trips. So those are two when I might be making an announcement. If the date is uncertain and I get it right before and don't have time to announce it in class, I'll put it on an announcement. But I'll use those, but they're usually only for big events. Grades. We have a lot of grades in this because, as you see, we're going to have a lab every chapter. We're going to have tests after every chapter, and we do lots of chapters. So it's going to be grades, grades, grades. And if I don't have a little bit of office hours here and here, I may not have time to put them in until over the weekend. I'll try to get them in as soon as I can, but as you see, I have a lot of classes and a lot of that means a lot of grading and very few office hours. So I'll try to get them in as fast as I can. Okay. I do not like this next sentence. It's so negative. Failure to use Blackboard could severely damage your ability to pass the course. I think that's way overstated, and it's so negative. If I were rewriting this, but they don't let me do it, I'd say the proper use of Blackboard could greatly enhance your ability to do well in the course. It says almost the same thing, much more positively and I think closer to reality. The next sentence is just crazy. See the schedule book. We haven't had a schedule book in years, okay? But they don't let me take that out, okay? If you need, anyone need help in Blackboard? Everybody familiar with Blackboard? Good, okay. And then that sentence is sort of irritating, if nothing else. Students should always check the Blackboard announcement page prior to coming to class. Why would they put that sentence in there? In case I've canceled class. And guess what, folks? I'm not going to cancel class unless something really major happens. I'll tell you ahead of time if I'm going to be late getting here or something like that. I'm going to try to be here every day. I'm going to try to be on time every day. It's, I have 10 minutes between classes, so sometimes I'll have to run down and exchange books, and if no one else bothers me, I should be back in 10 minutes. I find that just irritating, because I'm going to try not to cancel class. But do check it before the next class, because it may be delayed, it won't be canceled. Okay. For student learning outcomes, students will be able to demonstrate the knowledge of stars, galaxies, and the solar system. Okay? Demonstrate the knowledge of rocks and minerals, plate tectonics, building and shaping of the Earth's surfaces. Identify indicators of weather and climate. Demonstrate knowledge of Earth's waters. Work together in groups to solve laboratory assignments, and you'll perform research on topics in physical science, which includes a paper. Okay? Now, if you think back to the course description, it said geology, that's number 2 here. Demonstrate knowledge of rocks and minerals, plate tectonics, the building and shaping of the Earth's surfaces. Then it said, I think, meteorology, that's this one. Key indicators of weather and climate. Then it said oceanography, demonstrate the knowledge of the Earth's waters. And then it said astronomy, and that's demonstrate the knowledge of the stars, galaxies, and solar system. Well, why didn't I follow the course description in the order? Well, in the book, the order is this way. So I will go by the order in the book, because sometimes the book will refer to something we've already had. When we change the order of the thing, it will be referring to something we haven't gotten to yet. Not that often, but it will do it some. So, to match these, demonstrate knowledge of the stars. That's basically chapter 14. Stars and galaxies are chapter 14. The solar system is 15, and the Earth-Moon system is 16. So that's going to be our astronomy portion. Okay? And after 16, then is when we try to schedule the field trip to the planetarium. Okay? Then demonstrate knowledge of rocks and minerals. That's chapter 17. Plate tectonics is 18. Building the Earth's surface is 19. And shaping the Earth's surface is 20. So that's our geology portion. Key indicators of weather and climate. That's chapter 23. So we skip 21 and 22. 21 is something like geologic time, and 22 is the atmosphere. Wish we had time for those, but we just don't. This is a lot of chapters to do in a very short term. And demonstrate knowledge of the Earth's waters, that's chapter 24. And then the labs will be after each chapter, with the extra lab after 16 if we can schedule that. Okay? And then the research paper, we'll talk about that later, and then the comprehensive final exam. Which, it may sound sort of hairy, this is probably going to be the easiest test you take all term. Okay, and none of them are all that hard. But that is just a quick summary of everything we've done, covering all the chapters, but it's matching, so it's pretty easy to do. So let's get to evaluation and assessment. We saw what we're going to study. How will I evaluate and assess what you've got? And it seems like this first sentence is unnecessary, but they've got it in the syllabus and we're supposed to use it. Okay? A research paper is required for the class. I've mentioned it several times. We're going to go into the details a little bit later. It will count as a test that cannot be dropped, the research paper. The chapter test will be given at the end of each chapter. That was 14, 15, 16, 17, 18, 19, 20, 23, 24. So that was 3, 4, 7, 8, 9 chapters with one more possible lab for the field trip. So that would be 10 labs. Okay? 9 tests. Okay? Chapter tests. The lowest chapter test score may be dropped if it helps your average. That's why I'll put maybe in there. Let's just suppose that you don't turn in a research paper. Let's do that 0 because that can't be dropped. Then you'll need every chapter test you can to bring up that average. I don't recommend doing that. Okay, that's why I put maybe in there rather than will. There will be at least one laboratory assignment for each chapter covered. Like I said, after 16 we may have an extra one. So there's, what did I get up to, 10 labs. The lowest lab assignment grade may be dropped if that helps your average, which usually it will. But if you have all 25s or something like that, it wouldn't help you so much. Okay, the laboratory grade will be averaged from the remaining lab assignments. The laboratory grade will count as 25% of the final grade. Well, where did I get that? Well, let's go back and think about that first page. 3 credit hours of theory, the class type stuff, 1 credit hour of lab, that's 4 credit hours. One of those is lab, that's 25% of the grade. So after every lab, I'll actually grade each lab on 25 points. So at the end of all the labs, if I drop the lowest one, you get a lab average that's something between 0 and 25 points, hopefully closer to 25, right? Okay, and then, so that will be your lab average. It will be average, that's called your lab average. And the laboratory grade will be 25%. The average of your paper that can't be dropped, the remaining test scores, if I do drop one, and the comprehensive final exam, which you cannot drop, I will take that average out of 100, take 75% of it, 3/4 of it, add that amount to your lab average, and that gives you your final average. Okay? Remember, the comprehensive final exam cannot be dropped, and the research paper cannot be dropped. So when you add those up, if you're in the 90s range, you get an A. 80s a B, 70s a C's, and don't mess with the rest of them. Don't even think about going down that road. Most of the time, people do not. Those that do, it's because they missed tests, they didn't turn in labs, or they just, didn't do anything, didn't do what was required for the course. Now, I'm going to try to keep as much as possible of this on the page. Okay. Attendance expected to attend all classes for which you're registered. Students are unable to attend classes regularly, regardless of the reason, whether it's excused or not excused. It doesn't really matter. You're not here, you're not getting the material. So, and if you're not in class, you're not able to do the labs, you're not able to take your tests, you get way behind, you could get yourself in pretty serious problems there. And so they say you should consider withdrawing before the poor attendance interferes with your ability to score well in the class. Withdrawal can affect your eligibility for federal financial aid, but guess what? A D and an F, either one, is going to affect your ability to get financial aid. And they affect you in exactly the same way. For federal financial assistance, they will pay for you to retake a class once. Okay? You make a D in a class, you have to retake it. They'll pay for you to retake it once. If you fail a class, of course you got to retake it. If you withdraw from a class, of course you got to retake it. So, whatever your circumstance, if you do either a D, an F, or a W, you're going to have to retake the class. Okay? If you have a D, that's going to hurt your grade point average. If you make an F, that really hurts your grade point average. If you withdraw, it doesn't affect your grade point average at all. So, if it looks like you're at the end of the term before the withdrawal date, it looks like you're down in this territory and you can't possibly get out, then by all means, it's a better idea to withdraw. Now, if you've already made a DF or withdrawn before, another DF or withdrawal, you're going to have to pay the next time, but the DF will hurt your grade point again, and the withdrawal will not. So I don't see any reason, if you're going to make a D or an F, or it looks like you're going to, you can't get around it, then go on and withdraw. I don't see any reason not to. Now, certain programs like Allied Health or Auto Mechanics, well, I don't even think auto mechanics. It might hurt in Allied Health. Don't take this course. So I don't see any reason not to. Okay? Makeup work. Now, we do the labs in class. Okay? Most of them will get finished within one class period. And by the way, the labs are set up for 2 hours. And if you notice, the classes are an hour and 50 minutes, and then the labs are an hour and 30 minutes. So we're not going to do that every day. What we're going to do is we're going to cover as much material as we can in a given chapter. Okay? If that goes past the hour 50 mark, the hour 30 mark, okay, and we don't have time for the lab, we're going to continue in that chapter. And then we'll go and start the next chapter maybe. So anytime that we have a lab that's going to come up one day, I'm going to allow you 2 hours to do the lab. That's what they're designed for, okay? And so we'll cut class early and do the 2-hour lab, or we'll go to class longer and wait the next day and do the 2-hour lab. Now, on those days which were scheduled for a test, the test is going to be the last 30 minutes of whatever day that is. The lab will be the previous 2 hours from that, and then the class will be whatever is left over at the beginning. The reason I do that is, if we did it any other way, then some of you are sitting around waiting for others to either finish the test or finish the lab, and then we're having class at the end, and that's taking you right up until, what time is it, 5:30? Okay? Whereas if we do the test the last 30 minutes, the lab 2 hours before that, and then class before that, we finish the class, everything we're going to do in the class. If you finish lab early, you get to start your test early. If you finish the test early, you get to go home. You don't have to sit around waiting for someone else to finish your test or lab. So that's why I do it that way. Is that okay with everyone? Even though we may be on a different chapter in the first part of the test, you've already finished the test and you're ready for it at the very end. Is that okay? It just seems to work best that way. That way we don't have people sitting around waiting for someone, who needs a little extra time to do the test. Okay? I don't want to chop off their ability to have extra time, nor do I want you sitting around when you could be heading home. Okay? So that way it seems to work out best. So we're going to do the labs, and basically most of the labs, not all, but most of them, you'll have time to finish in class. Okay? There's one that you might not have, maybe a couple others, but most of the time you will. If you want to turn it in at the end of the lab period, you can. Okay? But if that's the last 2 hours of the day, you've got everything done, you need to leave early, you can take it home and finish it at home. And that's why I say that lab assignments are due within a week. I always want to give you a week to turn them in. That way, if you do have questions, you get home and you can't remember, oh wait, how did we get that? And you need to ask me questions, you can do that. Okay? So try to get those labs turned in within a week. Most of you, for most labs, are going to turn them in that very day. But I do give you a week to get them back in. Okay? If you can't make that schedule, please let me know, and we'll work out a plan to do it. Because guess what? We're going to be having a lab, once we get going, we're going to be having a lab most days. Not every day. Because like you saw, we have 10 labs in 10 weeks. So usually one lab a week, either the Tuesday or the Thursday, one or the other. Okay? Mostly. Okay? So one day we won't have lab, one day we will. Or vice versa. Now, if you have to miss a scheduled test, please try to get that done within a week. Now, summer, I have had some students who are in, say, Army Reserve, National Guard, or something like that. Are any of you? No, okay. I have had sometimes someone's going to be gone for 2 weeks. Guess what? We accommodate that, okay? I have had a couple of times that students have had internships, maybe for 3 weeks. That's sort of tough, but we accommodate for that. You just have a lot of catching up to do when you get back. But if it's anything else, try to get those tests made up within a week. I don't want you having being 1 or 2 or 3 tests behind. That we're already on test 5 and you haven't done test 3 yet. Try to keep up. You know what else it does? If you haven't turned in a lab or haven't turned in a test, I can't return those to the rest of the students. because then the correct answers would be floating around out there, and someone, eyes might wander or something like that, and that would cheapen your grade and give that person a really good grade, because I always write the correct answers on there. So, try not to hold up the rest of the class. Let me put it that way. Okay. And please let me know ahead of time if you are going to miss a test. Lateness, we're going to try to start on time. Today we couldn't because I had all those interruptions in between. But this is first week of class. Sometimes those things just happen. I'm going to try to start at 12 every day. But like I say, I only got 10 minutes in between. I have to usually run down and swap out books. And if anyone catches me in between, which they did today, I could be a little late. Students expected to arrive and prepare themselves for class before the class period begins. Students who miss work due to lateness, blah, 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 blah. Okay. You've seen all that before. Any questions on that? Now, I imagine, are most of you Lawson students or some of you transient? Any transient? You're transient, okay. So you may not have seen these, but I know you've seen something like it because it's almost required for us to do. Statement on discrimination and harassment. Let me just summarize this. You'll see this written here twice. Will not be tolerated, is never tolerated. You get the idea? We don't want it happening here. We don't want it happening at Lawson. Okay? And I've been here, this is my almost the end of my 21st year, I believe, and I have seen basically zero. Okay? Doesn't mean that it hasn't happened, but it just hasn't happened where I can see. I've heard about a couple of things. Some of them may not actually classify as discrimination or harassment, but let me just give you one example. The first several years I was here, I taught a class for the automotive program in math. So I got to know most of those automotive students. Most of them great students, great guys, they're just interested in parts. But occasionally we ran into some that were fresh out of high school, and most of them are. And I think the only reason they were here is because Daddy made them come to college. You're going to college, So they picked what they thought would probably be the easiest thing they could do. I like parts, so let me do that. So they did that, but they really weren't interested. And they weren't interested in automotive math at all. But that's beside the point. I had a student like that one term, and I heard sometime later he wasn't in class. Most of them always showed up to class. And I asked him, they said, "Oh, he's gone." I said, "Gone?" He said, "Yeah. One day at lunch, he just decided to walk across people's cars in the parking lot. They were parked right along there. He just was walking from one car to another up on the hood of the roof or whatever. Don't ask me why. Someone saw him, yanked him out in the dean's office for a short period of time and off campus, never to be seen again. Okay? Not tolerated. That kind of stuff. Now, to me, discrimination or harassment is worse than that. Now, I include bullying in this too. And I think that most students, if they're going to do it, they're not going to do it in front of me. Okay? So what I want to ask y'all, if you see or even sense that anything like this is happening, please let us know. Because we want to nip it in the proverbial butt. Now, we give everybody full, whatever they call it, due process and all like that, but basically we don't want it happening here. Okay? We take those charges seriously, even if it's against us. If you feel or sense or think that for somehow I'm discriminating against you, I'll help you get the report done. Okay? Get you to my supervisor and whatever. We take it seriously. That's honest. Okay. Now, Americans with disabilities. I think some of you probably have already noticed when we're talking about names and stuff or call and roll, sometimes I wasn't hearing too well. That's because I'm hard of hearing. Okay, I'm old and decrepit. So I'm sort of sensitive to this kind of stuff. We really want to accommodate whatever, if you have any type of disability. It could be physical like mine. It could be like reading dyslexia or those letters ADD or ADHD or whatever those letters are. There's a whole string of them. anything like that. If you have anything, please bring your stuff. It's your responsibility to provide the documentation to the college. I don't need to see it. Dr. Renee Herndon in this building, on this campus, is the Director of Disability Service, and Ms. Janine McCoy-Jones is in charge of it over on the Birmingham campus. She works under Dr. Herndon. So please get one of them your documentation. They will get to me what I need to know. Nothing beyond what I need to know. If you bring it to me, I just take it straight to them. Okay? You can go to Lawson State webpage, click on Student Services, and follow up on that. Here are the locations on this campus. It's in this building. Down on the first floor, the Student Services wing. Y'all mostly come in those big glass doors, and what I call the back of the building, most other people call it the front of the building. Okay, when you come in there, that's the admissions desk is right there, the information desk right there. It's to the left of that. Just ask at the desk, they'll walk you back there, and they'll have her come out, because she's real close to that desk. On the Birmingham campus, it's in the Leon Kennedy building, which sometimes is called the Student Center building or the Student Union building, but that's the Leon Kennedy. On the first floor is the cafeteria and police and a few other things there. Up on the second floor is the bookstore and the Space Center and some other offices like that. On the Birmingham campus is in the Space Center. That's where Ms. McCoy-Jones is. So there you can see the ADA counselor. Now, obviously I don't have the course calendar done, okay? That was, like I said, I could not change anything. I tried to update syllabi while I was on vacation, could not get it to do. I don't know if it was the fact that it was through our website or if it's the fact that it was Karen's computer was Apple. I don't know why, but I couldn't get them done. So these are all incorrect. These are for last fall. I'll get the ones. If you want to see something sooner, you can go to the Lawson State webpage, okay? And then at the top of the page, there's a whole bunch of tabs, and one of those says Academic Calendar. You can click on the calendar, and then it actually is a calendar month by month by month, and it shows all these dates on it. I'll condense that to a table and put it there. I'll just show for this summer, okay? Then, when I've got all these updates done, everything corrected, then what I'll do is put this on Blackboard. I'll let you know when it's out there. Then if you'll go to this last page, you got one or two options. You can just print off this last page, sign in, print your name, and print the date. Or you can do it, type it in, your name and date, and send it via electronically, either via Blackboard or email or whatever, however you want to do that. All right. Except for those changes I indicated, any questions on the syllabus? You see what we're going to do, when we're going to do it, how we're going to do it. Okay? So I will end this, and we'll go to the research paper instructions. Whoa, too much. All right. You get to choose your topic. We've got tons of topics you can choose from. Anything to do with astronomy, anything to do with geology, anything to do with meteorology, anything to do with oceanography, okay? Anything within the scope of the course. We're going to run into several people that you can write on those people. You can write on theory, Big Bang theory, plate tectonics theory, any theory that you want to do. You can write on a phenomenon. Black holes, neutron stars, pulsing stars. Pick any kind of phenomenon. Tornadoes, hurricanes, anything to do with any of it. The Gulf Stream, there's tons of things you can choose from. Earthquakes, volcanic activity, any kind of phenomenon like that. Applications, okay? This could be, depending on your major, say if you were a business major and you wanted to tie weather conditions with business, how they hurt your business, how they may help your business. You're selling snow shovels. Snows will be a good deal for you. If you need to be open as much as possible and weather shuts you down, that would be bad for you. So if you have applications like that, you can do that. Any other such topic about which you have an interest. It doesn't have to be anything to do with your major. If it's just something you're interested in. You always love reading about tornadoes. Yeah, you can do that, even if it has nothing to do with your major. Here's something else. You could write on an internet application or demonstration which you find useful to the class. I can't think of too many specific examples of this, because I don't think I've had a student write on this, but you could if you wanted to. I remember one student sent me a slide. He didn't do his paper on it, but it was the relative size of various celestial objects. It started with the Earth, and then they showed the moon next to that in proportion, and then Venus, Mars, and Mercury compared to the Earth, and then Jupiter, Saturn, Uranus, and Neptune compared to the Earth. The Earth is pretty small. Pluto and some of the other, and took it on up to stars and galaxies and things like this. If you found something like that and wanted to write on that, sure, you could do it. YouTube demonstration or thing that has something to do with this course, if you choose to write on, fine with me. Now, what I'd like you to do, either today or next week, is write your name and a topic you're at least considering now to write your research paper on. Okay? Your name and the topic you're interested in. That's not very much material to put on a single sheet of paper, so the rest of what I'm going to say right now has nothing to do with the paper, but it has to do with sometimes situations. And it doesn't happen that often, but it does occasionally, so I like to be prepared for it. Every now and then, I'll have someone run to my door when I'm in class or give me a phone call when I'm in the office and say, listen, so it's in your class. Do you have a good phone number for them? The numbers in the system, we can't get an answer. We don't know if they're the right numbers or not. And so if you want to give me your very best phone number, you can do that. You don't have to. It's not part of the course. But if you want to give it to me, since you're taking a piece of paper anyway, you can give me your very best phone number. Only people I'm going to give it to is administration of the college. Not another student or anything else like that. Just somebody who needs to know from the college reason. Okay? Now, if that very best phone number happens to be a cell number, which I'm going to guess most of you it would be, and there's a chance that either your battery died, you left it at home, you left it in the car, you left it in your book bag, or it got run over by a truck, or you changed services, or something like that, and that number might not always be good. If you want to give me a good backup number, Mama's landline or something like that, you can do that, but you don't have to. You can if you want to. Now, a lot of times I have students who also work. Okay, I don't know if any of you do, but sometimes I advise students they needed all their classes on Tuesday, Thursday, because they wanted to work as much as they could on Monday and Wednesday. Well, if at your work, they don't like you talking on your cell phone, or Mama can't, that won't do any good for me to call home. If you want to give me a work number, that's fine. I can't think of any reason I'd need any more than one of those three numbers. I don't need any of them if you choose not to give them to me. So you can give me 0, 1, 2, or up to 3 numbers if you wish. You don't have to. Do give me your name and the topic. Okay, back to the class. You will need to find at least one outside source. 2 or more are better than 1, but at least 1. Now, this book has a lot of really good features in it. In every chapter, there's some person behind the science. Generally, close to a full-page article on that person. That can't be your source. That can be the idea for the source, but that can't be your source. That can be your idea for the paper, but it can't be your source for the paper. You need to, if you get an idea like that, you need to find at least 1 or more outside sources. Now, those can be any other book, journals, articles, magazines, newspaper, anything that you would find in the library, or, and this is a real tough one here, any legitimate source you find on the internet. Okay, problem with the internet, 2 big problems. At least half the stuff on it is total garbage. Okay? Second problem, sometimes we don't know which half. Okay? So before you use the internet, if you're not certain it's a good, reliable source, like if you find a source that swears the moon is made out of green cheese, don't use it, okay? Because it's not. We've been there, and we know it's not made out of green cheese, okay? So if you have any question about whether it's legitimate or not, run it by me. I'll take a look at it and say, I don't know if I trust this. They don't give them any documentation. Or, hey, no, that's great. That's good, reliable source, okay? So, but remember, the textbook is not your outside source. You have to have at least one, two or more better outside sources. Your paper must be at least one word process page of text. Now, double space, not single, double space, and regular font, 12 pitch or 12-point font. Okay? Now, what do I mean by one word process page of text? Now, you don't have to do this, but students quite often will do a paper with some sort of a header on it. Okay? Maybe that's all their English papers require that. I don't know. That's fine. You can do that. Then they skip a few lines, and then they put the title. And then they may triple space, and finally start typing right about here. Okay? To be one page of text, it's going to have to go to the bottom of this page, and then on the second sheet of paper, all these are going to require at least 2 sheets of paper. It's got to come down past the header and everything, and get to that line there for it to be one full page of text. Otherwise, people do all sorts of stuff and just print a little bit. You know, that doesn't count. Okay, that's going to be a page of text. Okay? Now, double space, this is single space, so you get the double space, and that still counts, one page of text. Going to be on at least 2 sheets of paper, but one page of text. And the 12 pitch or 12-point. I don't want 9-point or 9-pitch, whatever you call that. It's so small, it hurts to read, you know. I need it double space so I can make notations, okay? I don't want any 26-point that 4 words fill up the page and you say you're through. That's not going to work either, okay? So make it, you know, reasonable. The font you use is up to you as long as I can read it. I don't read hieroglyphics or Old English or Greek or any of those others. Keep it something good and readable. This happens to be Arial. Fine, there's others that look just like Arial. They'll work. Times New Roman. That's the default for a lot of the word processing packages. Perfectly fine. Courier. There's tons and tons and tons of great looking fonts. Just make it so it's easy to read. Try to keep the paper less than 2 pages. You know, I said one page of text is going to go onto the second page. Try to keep it less than 2 pages. If you get so interested in it and so fired up about it, it can be longer. I don't take off points for it being too long. I do take off points if it's too short, if it's less than 1 page of text, but there's no penalty, outright penalty for it being too long. Now, I haven't had this happen often, but it has happened at least 2 or 3 times over the many years and many papers I've read. I've had some people that sort of, for some reason, think, well, I don't write very well, so therefore I'm going to write a lot. Okay? And they try to replace quality with quantity. Don't do it. Okay? Because, and I'll give you the reason for it. When you turn in a paper to me, it's a 100-point paper. Okay? And then I start reading it. And as I read, if I find errors or this or that, you start losing points. So, if you turn into me a really sloppy, poorly done, 15-page paper, not that I don't think any of you would do this on any part of that, but, and you are losing points, guess what? That's going to wind up with a worse score than a 2 to 3 or 4-page really well-written paper, because I go for quality, not quantity, okay? And don't turn me in lots of garbage. It's a lot harder to read than a short, concise, really well-done paper. So do that, okay? You can use any format you choose. Most English classes teach MLA, Modern Language Association format. Perfectly fine if you want to use that. A lot of the sciences and other areas, APA, American Psychological Association, came up with a great format early in the process of doing this, and other people said, wow, I can't improve on that, let's use that. So a lot of people use APA. If that's what you want to use, fine. Now, if any of you are doing research in your field of study, your other things, in your particular area has its format that they want you to use, you can use that. I don't care, okay? But whatever format you use, stick to that format. Don't be jumping around. I give this example because unfortunately I've seen it. I like blocking paragraphs. That's why I blocked all these paragraphs. But I've seen some people who block a couple and then start indenting. Actually indent this one to here and this one to over here. That's not being consistent. You're going to lose points for that kind of stuff. Okay? Here's another one I've seen as far as format goes. Say up here they quote a source. And let's say that they open parentheses, put the last name of the author, comma, year of publication, close that, and go on. Okay? If that's what your format calls for, that's perfectly fine. But then down here, they have the same type of an article here, but a different one. And they open parentheses, put the title of the article, comma, page numbers, close it. That's legitimate in some formats, but obviously you're not using the same format. You're not being consistent. Now, I think I know what happened. Probably this book that they used up here probably used the format that you used here, and this one down here may have used a different format, so you use the format. No, that's not being consistent. You choose your format and then do all your citations with the same format. Now, I know that books and journal articles are going to have different formats. I understand that, but when they're the same type of source, they should have the same type of format. Okay? So watch out for that. Spelling, grammar, sentence structure, all those things that English teachers like to take off for. If you have errors in them, those are errors. Okay, now I may not take off as much as they do, but you will lose points for those. So guess what? Every word processing package I know of nowadays has spell check, and I think most of them have grammar check. Use them. There's no reason not to. Okay, except for this reason. I forgot this one. It's late in the term, and you haven't done a thing on your paper, and you type it up real quickly and turn it in without bothering to spell check or grammar check or something. So don't do that. Get started early and do a good paper. Okay? Use good proofreading too. Content also matters. Let's just say that you decided to write on Edwin Hubble. Okay? Great astronomer, famous. Hubble Space Telescope named after him. Hubble's Law named after him. Really good, okay? And maybe not with him, but I've seen it in other things. When first paragraph or a sentence or so, someone says Edwin Hubble and put in parentheses. You don't have to do this, but the person chose to. Date of his birth, comma, date of his death. Close it out. And then over here on page 2, they have he died a different year. Now that's not being consistent. Something's a little off there. And it wasn't that long and boring of a paper, so it couldn't have been that was the reason. So, be consistent. So content also matters. I'm trying to think of an example for this class. I can't write off the top of my head, but in math classes, I've had people write on Pythagorean theorem many times, but give it to me wrong, okay? Or have them write on, just pick a topic, a subject, and then they'll say something I know is absolutely wrong. I think I see where they made the mistake, but it was a mistake. So the content also matters, so be careful with that. Paper is due by the last day of class. That's not the last day of the finals or anything like that. The last day that we meet together as a class and have class. That's when it's due. But please don't wait for that long. You'll never have more time to work on the paper than you do right now. That's why I want you either today or next week to give me a paper topic. So you start thinking about it now. And then shortly after that, get started getting your materials together, researching and stuff. You might say, hey, I don't like this topic. Or, wait, this is way too big a topic. Or, whoa, I can't find anything on this topic. Well, then you can change. That's perfectly okay. But I want you working on it, thinking about it early, not putting it off till the end of the term and then turning me in a sorry paper. I'll just say this. I meant to say it in my first 2 classes today. I forgot it. Like I said, this is, I think, my 21st year of teaching here, almost in this classroom. Okay? And I've taught every term. We started on quarters, so that was 4 terms a year. We've been in semesters now for a long time. That's 3 terms a year. I've had anywhere from 4 to 8 classes every term. Okay, I've never had fewer than 4, I don't think. Never had more than 8, thank goodness. Okay, And I've had, this is probably a little smaller than my average class size, but 15, 20, something around there would be average class size. That many classes, that many years, that many terms, that's a lot of papers. Well, this is a gross generalization, but it's pretty close to true. Most of the papers I get in early in the term are usually my best papers. And there's some variation, of course, in here. But generally the trend is this. And toward the end of the term, I start getting in some really bad papers. Now, I've had some dogs in the beginning of the term, and I have some great papers at the end of the term. But the general trend is downhill. Because you get it done when you have the most time to proof it, that kind of stuff, you usually get a better paper. Okay? Those done last minute, throw it together, generally aren't that good. Okay? So try to get them in early. Okay? If your paper is submitted after the last day of class, that's not the last day of finals, the last day that we meet as a class, you'll lose points. Okay? That's the stick. Okay? Here's the carrot. If you turn in your paper in the month of May, and we only have a few days left of May, but you get 3 bonus points. If you turn it in the month of June, you get 2 bonus points. If you turn it in the month of July, but not the last week of class. I don't remember when the last week of class is, but it's a Tuesday, Thursday, or Thursday, Tuesday. The last 2 classes, that's the last week of class. If you turn it in July before that week, you get 1 bonus point. If you turn it in that week, the last week of class, you just get your score. You turn it in after that last week of class, you start losing points. Okay? Make sense? All right. Now, one other thing. Most instructors don't require this, but I do. When you submit your paper, let's say you have 2 or 3 or 4 or 7 or 1 source, whatever, no matter how many sources you have, please print me or copy me a single page from just 1 source. If you have 3 sources, pick one, any one, and just give me a single page from that source. If it's a source from the library, take it over to the copy machine, copy me a single page. I don't need the whole paper. Don't need the whole chapter. I just need a single page from that source. If it's something you got offline, just print me a single page from that source. Okay? Any questions? As soon as I get the days and stuff correct, or months and stuff corrected, I'll get this out there, put it on Blackboard. By the way, I put these things under content. So that's where you look for the syllabus, research paper, and then what we do next. Any questions before I move on? Okay? So I'm going to close this. No, I'm going to actually, my next class is over on the Birmingham campus, so I won't be using it. Now, this is what they call, I'll show you from the beginning. Wrong way. It's what they call our locator card. Now, this was from last summer, not this summer, but you'll see a lot of things are the same. My name's the same. My office phone number is the same most of the time during the week. My email address is the same, and I'm technically in the mathematics department, even though this is physical science. I teach in both areas. Okay, and what is the same here across the board, I usually come in by 7:45. This morning I was here close to 7:15. It's a lot earlier than normal. Usually it's closer to 7:45, but I have 8 o'clock classes Monday through Thursday. So I'm not in the office much, but I am before 8 o'clock every day, unless for some reason that I can't be. Now, Friday, the off-campus is not quite true. I'll describe that a little bit later. But this part is true. On Monday and Wednesday, I have Calculus 1 in the morning, Monday and Wednesday, and because it's a 4-hour course, but we're only here 10 weeks, that's 2 hours and 40 minutes. So it's from 8 to 10:40. Okay, now I put lunch there. It's not 15 minutes. Actually, it is usually less than that. I usually try to get a bite of something there. Okay. Then I have Cal 2 from 11 o'clock until 1:40. Okay. I don't know why this page is even here, but I can't get it to disappear. Okay. So then I put another 20 minutes, I might eat a little more lunch. But I'm in the office for those two 20-minute periods. Now, here's the difference. This was last summer. Every summer we flip these, and so this summer it's 202 here and 201 here. Right now, the 202 class has fewer than 10 students. If that remains to be the case, then we're going to stack that with 214. I think I described that earlier. And so Dr. Bryant will probably wind up teaching that stack class. Okay? If he does, then I'll have office hours between 2 and, well, I'll eat lunch, there too, between 2 and 5:30. But at 5:30, my 201 class has got more than 10 students, so that will go from 5:30 until 9, and then I'm off campus by 9:15. In fact, I'll probably just move off campus up there because I'm going to leave as soon after 9 as I can. All right, Tuesday, Thursday, which is probably when you are more interested. Let's see if I can get as much of this as possible on the page. All right. Again, I'm here usually 15 minutes early before 8 o'clock. But I have a differential equations class from 8 to 9:50. Then I have 10 minutes in the office. Let me back up. Last summer, my linear algebra class didn't make, so I had office hours starting at 10 o'clock. This term, I have 6 people in it. I don't know if they're going to let it run with 6, but if they do, then I'll have a class from 10 until this goes until 9:50, and so I have 10 minutes, and then the next class, linear algebra, starts at 10 and goes to 11:50. Okay. Then this class, I have 10 more minutes there. This one starts at 12 and goes to 1:50, and then the lab starts at 2 and goes to 3:30. And then it says office advising. That's really trouble, because I'll leave this campus, go to the Birmingham campus, and last summer I didn't have this course, but at 4 o'clock physics until 5:30. So my off-campus is then moves down to 5:30. Okay, on Tuesday and Thursday. So you see, I have 10 minutes right now. 10 minutes, and no time in between these two classes. That's all the office hours I have on Tuesday, Thursday. Now, if this class doesn't make it, then I'll have it just like this, from 10 until 12 office hours with lunch in the middle of it. Okay, but I don't know. And if this class doesn't make, then I'll have office hours there too. I'm kind of rooting for the classes not to make. This one will be taken care of, but the thing is, I still have a late class that goes until 9 o'clock. So, but at least I have office hours to grade. Now, let me explain Friday. I think I did earlier, but on Friday, this Friday, like tomorrow, and next Friday, the last Friday, actually it's the first Friday in June, I will be on the Birmingham campus from 7:45 until tomorrow. I'll probably be there until 3:30, something like that. The next Friday, actually, I think I have an infusion that Friday, so I won't be on campus at all. I'll have to check on that. And then June and July, the rest of those Fridays, we're not even on campus. And then the first Friday in August, I think, is the only Friday we're back for summer, and I'll be on campus there, 7:45 to 11:45. All right, any questions on my schedule? Okay, this is easier sort of to picture than just writing down the office hours. Okay, I think I'll be through with that. And I've already done that, so I believe I'm through with this. So, now it's time to really get into physical science. And it's almost 2 o'clock now, and we go to 5:30. Do you want to take a break now, or you want to go to about midway?
3:30.
Huh? 3:30, yeah, I'm sorry. It's probably 3:30. I was thinking about next class. Yeah. Okay. So we've gone an hour and 50 minutes so far, and we've still got 2.5 hours after this. Is it? No, 1.5 hours. So yeah, this is about midpoint. Do you want to take a break now? Or we can go with no break. It's up to you. Okay, let's take a break. Let's try to keep it 5 minutes or less, and then we'll come back and get going. Now I'm going to put this on pause. All right, now were there any questions over anything we went over before? Syllabus, research paper, locator card. Oh, I've forgotten this in my other classes too. Really need to do this. I hate to take time to do it, but it's something we're supposed to do. We need to talk about safety, okay? Now, there's nothing we're going to be doing in the class that is going to require any special safety precautions, but we need to talk about general safety. And I just happened to remember this when I said that about he was getting the kids out of school early. There are 3 areas of safety we need to think about. Can anyone think of one of them? Second? Yes. Weather situation. Could be tornadoes, severe thunderstorms, anything like that. If we hear that siren go off, we need to pay attention. Okay? It happened to be I was teaching an evening class here. It had been 15, 20 years ago. And the alarm went off, and I looked out. It was like 5:30, 5:45, something like that. I looked out. Not a leaf was moving on a tree. Nothing, as still as it could be. I said, must be a false alarm, because it wasn't the 11 o'clock test. It was, so I went on teaching. After a while, the evening coordinator said, get downstairs. There's a tornado pretty close. And what it was the one that was up at, where's that?
It was the one that was in
Okay, this was several years ago, maybe before y'all were born. I don't know. What's the town? I can't think of it now. But they had a really major one, did a lot of damage to a high school. Sort of. No, that was later. No, Oak Grove. Oak Grove, I think it was. Anyone from that area? I think they have a new high school now because the tornado destroyed the old. Okay. And like I said, not a leaf was moving on a tree here. It had sucked all the energy over to that, and there wasn't anything happening here, but it was going on a path that we were within the parameters of the path. So yeah, we have to pay attention when that happens. So what happens if we hear that weather emergency go off? What do we do? What are the rules? Say again? Take precautions. What would they be? Well, if it's the weather siren going off, then generally for that, we're always going to go low and interior. Those are the 2 things to remember. But what does that mean for us here? Well, right here is where we are. You go out this door, hang a left, go down that half flight of stairs right there, take an immediate left there, go down one more flight, and you're almost as low as you can go in this building. So we're in the low part right. Interior means anything on this side. Nothing on the outside, okay? Everything interior. I'll tell you some of the best places to be in certain senses. The restrooms right there, right in front of you when you come down those stairs, they're actually pretty safe to be. And here's why. The walls are close together and lots of right angles, okay? That gives the greatest strength, okay? On the negative side, who wants to be in the restroom for a couple of hours? You know, it's maybe not the nicest place to be. Okay? So after the restroom, underneath this corridor here, there is a room down there. Go down just a couple more steps. It's the academic dean's office on this campus. Now, she was here earlier today because she came to see me in between classes, and that's what helped me out. If she's there, or the associate dean, or any other faculty member that's using that office, that's a pretty safe place to be because, again, it's a small space, interior, walls are close, and lots of right angles. Okay? Now, this back side back here is all soil. There's not a outside of wall, that's it, underneath the ground wall, the basement wall, you might say, is on this side. So that's a very safe place. Right down from that is a classroom, just about under this one, which has bigger area, but it's still interior. Especially that back wall, really good, strong wall. Near the corners, really strong. And on either side, not bad. And that wall is not bad. The middle of the room, maybe not the best place, because if something does happen upstairs, above, things can cave in. The walls give you the greatest strength, especially at the corners. Right next to that, there's the glass door in the hall. That's the library door. And just inside that, on the right, is a computer room. That computer room is smaller than the classroom. Again, lots of closer walls, not as close as the restrooms and stuff, but still right angles, not a bad room to be. Just next to that is what I call the research room of the library. It has things like globes and atlases and things, not books you check out, but things you can use for research. And that's a little bit bigger than the computer room, but not as big as the classroom. So again, the walls are safest, the corners are the most safe, the back wall is next most safe, and then the other walls are okay too. Don't go any further in the library, because any further in the library, you're hitting windows. You're getting exterior walls. So don't go anything on this side or on the back side. Okay, so that's it for now. When we get down there, right now, all of you look like able-bodied people. I don't know about Adam Christopher Lee. It could be he's not here because he just turned a knee or something, okay? And he may be on crutches, okay? I'm just making this up. If that's the case, and we have an alarm like that, I'm going to be going down with him. I'm going down with the last person out because I want to make sure everybody gets down there. So y'all are going to be ahead of me. Okay, y'all move, not run down the stairs, then we have more injury. That's not good. Go down, quickly but safely. But I'll be coming along with the last person. Now, what I'm also bringing is the roll book. I don't have it in the book yet, but I'll be coming with the roll book because once we get down there, I have to account for everybody. And if we can't account for everybody, if someone said, hey, I got to go let the dog in or let that dog in, no, don't be doing that. The worst place to be is in a car. That's one of the worst places to be in severe weather. Don't be leaving. If we can't find you, we have to assume you're upstairs somewhere and someone has to go up, probably me, and risk life or limb trying to look for you. So please stay together. When I get down there with that last person, I'll mark the roll, someone will come around, and then they'll let us know how long it looks like it's going to be or whatever. Okay? So that's in case of an external emergency. Okay? What's another kind of emergency we could have? Say again? Okay, bad news, yes. Unfortunately, there's enough of these happening these days. We've got to keep it in mind. What do we do in case there could be an active shooter? In fact, remember, I'm hard of hearing. So y'all are probably going to hear first. Anything that might sound like it might be gunfire, let me know. What else do you do?
Close the door, turn off the light.
Okay, excellent ideas. Okay, but what else might we want to do?
Depends.
Yeah, but let's let somebody know. Now, surely someone else would call, but let's not bank on somebody else calling. The best thing to do is call campus police. And I used to have in my roll books, I didn't bring them up, or I took them back to my office and forgot to bring them back up here, is I have the campus police number on the speed dial. Okay, if you do that, good idea to do. If not, 911. Okay, call them and let them know that we think there's an active shooter. They'll probably say, hey, we've already heard, we're taking care of it. So that's the first. And not just close the door, let's lock the door. Now, when you said it depends, what were you talking about depending on?
Because if you're supposed to decide if you should run, hide, or try to fight him. So if he's across the school, we hear gunshots, you're supposed to just dip out the back door.
Right.
But if you're close, then you can hide. If he's right outside your door, then you don't have anything to do with trying to take it to him. You should stop. So you hope that doesn't happen.
Okay. Sounds like you've been through these drills before. Yeah. Okay. Now, we're going to assume they're far enough away that we can lock the door. I have a key for this door. The sad news is this door is lockable, but there's no button on the side to lock and there's no keyhole on the inside. I have to go outside to lock the door. Okay? So it depends. Okay? I will go out and get this locked as quickly as possible. Don't you be pulling the door off. Okay, guys, if you were thinking of doing that. Okay, so we come in, close the door with it locked from the outside. We can still get out, but we can't get in. But we got to get out of line of sight of this window. Safest place to be, right back here. He can fire it through a door, certainly through a window, but he has trouble firing through concrete wall. I have a feeling he'll get more ricochet on him than he'll get on us. So we all get back here, very quiet, lights off. He doesn't even know the room's occupied. Now, say he, most of the shooters, I can only think of one shooter that's a female, but most of them have been hymns, unfortunately. Okay? So we get over there. But we have another entrance to this room. Okay? Through these offices in that room. I don't have a key to that outside room. Okay? Outside office door to that. This door does have buttons on the side. I can press that one and it locks. But it locks from the inside, not from the outside. Not good. We lock ourselves in and he's still able to come in. So don't lock this one. Now this door has a deadbolt. But unfortunately I don't have a key for this deadbolt. So I can't do anything here. However, this door here has the buttons. Okay? It locks from the outside, which is what we want. Now, probably that's why we go to that other door, or y'all can too, close that door, turn off that light too. Okay? We can't lock it. But if you can lock that outer office door there, pressing the button that locks it from the outside, then we close it. Okay? He can't get in, we can get out. But we also close this door. We can't lock it. We close it because he can see through the glass. Okay? So we don't want him to see through the glass. We'll close that door as well. And then for safety, we can go and close this one too because it's lights out. We're over here. We're not making any noise. We dial 911 and nobody else. We don't want our phones ringing and we don't want us talking on the phone. Okay? 911 is all we do until we hear otherwise. Okay, and we stay quiet, we stay low, we stay out of sight, locked up if possible, until we hear that all's clear. And then we proceed out. Now, let's go to his third scenario there. That he's too close, he does manage to get in, and it's possible, okay, unfortunately. I want y'all staying back there. I'm 67 years old. I've lived a good life, or a long life, okay? Let me be the one who tries to deal with him, okay? You have a future ahead of you. Mine's mostly past behind me, okay? So don't you be heroes. I want you to be living to tell about it, okay? But don't sweat it. I'll do everything I can to talk him out of it, okay? But I'm serious. I'm serious, okay? I developed some heroes. Does the name Fukushima mean anything to you? Those were the nuclear power plants in Japan when they had the earthquake and the tidal wave, and it wiped them out and it contaminated like crazy. It could have been as bad as Chernobyl was in the Soviet Union decades earlier. But Japan had good things in place, but they just weren't expecting anything like that. And there was something that had to be taken care of. And it was inside the plant, and there was really no way to guarantee safety. Some old, retired engineers or plant workers from Japan that said, look, don't send in your current employees, let us go in. We know what to do, we will do it. If any harm comes, same thing. Let's save the next generation. So I took those guys as heroes for saying that, And I want to say the same thing. Well, I have the guts to do it when the time comes. Hopefully we'll never test that. But I'd rather it be me than you. Okay? So you don't do that until last ditch. Okay. So there's number 2. Outside active shooter. What other things might we need to think about safety? Fire. That's another interior thing. Now this includes more than fire. It could be chemical spill. So let's start with the worst case scenario. A fire starts in this room. Say my computer blows up and starts arcing and sparking, catching the paper on fire. What do we do? Second. Okay, if it's not arcing and sparking too badly, yeah, it'd be a good idea, but the fire's already going. Okay? So what do we do about the fire? Second. Okay, we certainly evacuate the room and we leave all the rest of the people to worry about it on their own, okay? We better do something else first. Yes. Oh, okay, you can, but let's just not forget to. And again, the campus police would be better if you have that on speed dial, get that number in your speed dial, but if not, dial 911. And I usually don't bring a cell phone with me in class, so because I don't want it ringing and going off and being bothered. It's down in my office. Okay, so y'all have your cell phones, y'all dial 911. Okay, what else do? We evacuate the room, but it started in here. And it is just a paper fire and wood fire. There's a little bit of electrical there, but if you got that unplugged, there's no more electrical. What else might we want to do since it started in our room?
Pull the fire alarm.
Oh, okay, excellent. 2 excellent things here. You said fire extinguisher. Where is the closest fire extinguisher? Okay. This, we're really fortunate. Out the door here, on this wall right here, 5 feet from where I'm standing. 5 feet. You can't get much closer than that. There's the closest fire extinguisher. Someone go get it. You've always wanted to break that glass, right? You guys anyway. I don't know if you girls think that way or not. That'd be so cool. This time you get to do it, okay? And if you aren't comfortable with it, I'll do the fire extinguisher and deal with that, okay? Because I want to be the last one in here anyway, okay? And pull a fire alarm. Where's the closest fire alarm? Unfortunately, we're in the old part of the building. Yeah, but guess what? Here's the old part of the building. It stretches from that end down there near my office, up here, all the way around here, and all the way there. Big U-shaped building. Not a single fire alarm anywhere in the old part of the building. Huh? Yes, exactly. Down here, if you're familiar with the admissions desk, the records office, financial aid office and stuff, there's a fire extinguisher on either wall. So what you do to get there, and I would suggest 2 people go, okay? Buddy system type thing. Go out of the classroom here, go down that take a left, down half flight of stairs, that corridor that goes across, go through that, take a right there, go across. You go through the double doors, there's 1 fire extinguisher to the left and 1 to the right. Fire alarm. Okay? So you go and ring the fire alarm. We want to let the rest of the building know the building's on fire, just we're not the only ones. That would also be the case if the smoke started coming out of the ventilation here. We're the first person to know. We go through all that. We don't need the fire extinguishers for that. We can't get into that room anyway, but we do all the things. But if we're not the first to know, or even if we are, and we hear the fire alarm go off, what do we do then? How do we evacuate the thing? Where do we go? Any idea? Huh? Closest emergency exit, and let me show you where that is. Go out the door, hang a left, go down that half flight of stairs, hang another immediate left, go down that flight of stairs, and then this time rather than going into it, you go out. That's the closest stairwell out. Yes? Okay. All right. Let me pause for just a minute here, and I'll be right back. Okay, so where do we go? We go out that door, and then used to just at 75 feet away from the building. far enough away so that if there is an explosion, glass gets blown out, you're far enough away not to get hit. Nowadays, they say go to the parking lot. More than 75 feet away, but go to that parking lot down there and stay together. You don't want to say, hey, building's on fire, I'm no more class today, I'm out of here. Get in your car and leave. Don't do that, please, because I go down, I'm with the last person out, remember, going on crutches or whatever, making sure everybody's out. We get down there, I call roll, we can't find you. Some fire personnel, safety personnel, somebody has to come into a burning building looking for you, or a building with chemical spill or something, come in, risking life or limb looking for you. So let's not do that. Okay, stay together. We call roll. They'll let us know what to do. They'll say, hey, you're right, no more classes, head on out. Or, hey, we got classrooms here and here and here. Why don't y'all go here? No, we'll manage. Okay. That covers the 3 types of safety. Any questions on those? Okay. Then, let's get started on physical science. Finally. Okay. As you remember from the syllabus, we start with astronomy. Why? Because that's the first chapter in the book. You notice it starts with chapter 14. And I think just about every physical science book I've looked at has physics and chemistry in the first part and earth science, astronomy and earth science in the second part. But good old Alabama, we do physical science 1 is astronomy and earth science, and physical science 2 is physics and chemistry. So we're usually backwards. So the chapters 1 through 13 are physics and chemistry, and 14 through 24 or something like that is earth science, astronomy and earth science. So we're starting in chapter 14. If you get the small book, that's where it begins. You don't need to buy the big book. You can buy that. It has just about everything that the big book has. The only thing I haven't found in there is answers to some of the questions. Okay? But they're not that difficult or involved, so you might not need those anyway. Okay? The core concept here, and if you're in the text, you see this is on page 353. Now, by the way, if you happen to have an older version of the book, there's my cynical view on this. These book publishers, I think, force their authors to come up with new editions about once every 3 or 4 years. Does that mean there's been that much new physical science in the last 3 or 4 years? No, it's that the publishers only make money when they sell new books. They don't make any money on used books. And if it's been out there for a few years, there's lots of new used books floating around, and they're not making any money, and they want money. So therefore, they make them, even though the changes are cosmetic, they change color, they put a few more figures or something like that, generally the text is hardly ever changed. Most of the time, the questions are hardly ever changed. It's just hardly anything is changed except the appearance and the price tag. So, if you can find an older version, cheap, you're probably not going to be hurting any way at all. The page numbers won't match, but you can usually find where we are. But on that first page, and in the current edition, it's on page 353. Here is the core concept. The night sky is filled, whether you can count them or not, you can't, billions of stars. The sun is just one very average, very ordinary star with average brightness, average temperature, average just about everything. Not a very remarkable star at all. Okay? Now, I don't know if you have a clue of what this is. This is a time, how do you phrase that? It's a photograph, but what you've done, it's a very dark night. You're out in the middle of nowhere, okay? No city lights anywhere around. And you've got your camera aimed due north, and you're pointing to the North Star. And what you do, dark night, pitch black dark, and you have your aperture open, wide open. Never closes. Not like you're snapping a picture and opens and closes. Wide open. Okay? And what you see here is the paths of the other star apparently going around the North Star. Is that what's happening?
No.
Why not?
Is the world?
Yes, the stars are fixed in place pretty much. We'll see later there are some major speeds going on, but they're in such a large space you don't notice. But what's happening is the Earth is spinning, okay? And if that's north, which is approximately doing like this, and we're here, it looks like the other stars are moving around the North Star, but the North Star never moves much. It may wobble a little bit just because it's not absolutely due north, but it's awfully close. But these are the paths of the other stars overnight. Okay? We'll see that and talk about that later again. Okay, in your text, this, by the way, my slide set is from an earlier edition, so it's not quite matching what's in your text. If you're looking in your text, you see a really pretty it's called a ring nebulous. And we'll talk about this a little bit later. The place is fairly uniform here. What a nebulous is, you may have heard the term, oh, that's pretty nebulous, okay? What a nebulous is a cloud of dust, basically. That's all it is. No organization to speak of. This has a little bit in that it looks like things are being pulled in a sort of irregular pattern, okay? If it was truly nebulous, the dust would be just everywhere. Now, I think the color has been added or emphasized. I don't think you actually saw that. It probably is based on temperatures, but I'm not certain on that. But that's a ring nebulous, which is a cloud of galactic dust, basically. We'll talk about that a little bit later. So, the first topic in the chapter, this is one page over, the night sky. And this is where we started talking. Now, a lot of what we're going to say here and describe came to us from the very ancients. And when I say ancients, I mean beginning of time for mankind. Okay? Because in the beginning of time for mankind, they mostly lived outside. Okay? Maybe simple structures, but they spent a lot of time outside. They didn't have anything else. No TV, no radios, no cell phones, nothing else. So basically, they observed the night sky. Now, they also had very little light. Maybe the fire in the middle of the camp or something like that. But that's about it. There weren't any street lights, car lights, any kind of lights. So they could just look at the night sky. Now, what did it look like to them? Those very ancient civilizations, they knew nothing about the earth spinning. They thought they were very stationary, just like we feel like we're stationary. It's only when we see things that we say, hey, something's moving, and we always assume it's something else, not us. Okay? So, what they saw when they looked up, and I just picture them lying on the ground looking above them, it looked like there was a huge hemisphere out there, and in that hemisphere were these points of light. Okay? So, most of those points of light were the stars. And they indeed looked like point sources. Okay, now what do I mean by that? Let's move up in time until we have telescopes, binoculars, and things like this. If you look at the biggest star out there, the brightest star out there, through the most powerful telescope you can have, it still looks like a point of light. Okay? That's all it appears to be. They appear as point sources even when magnified as much as we can magnify. Now, do they really twinkle, twinkle, little star? Not really. It's that we have an atmosphere that is changing. Clouds, vibrations, other things. It makes it look like they're twinkling. So it looks like they're twinkling, but they're really not. Okay? Now, how far are they from us? We don't measure these in miles or kilometers. They're way too big a numbers. We measure it in light years. Light years. Does that sound like a distance measurement? Sounds like a time measurement. Years is time, right? But when they say light years, what do they mean by that?
How long it takes light to travel.
Okay. How far distance it is for light to travel in 1 year. Wait a minute. Isn't light instantaneous? Hit a switch. Doesn't light come on immediately? Sure seems like it. But it really isn't. There is a speed to light. Now, they give this in kilometers. I'm going to give it to you in units we're more used to. And the speed of light, this is a rough number, 186,000 miles per second in 1 second. That's how fast light is moving. 186,000 miles in 1 second. That meant if light were racing around the equator, it would go about 4.5 times before the second was over with. That's pretty fast, okay? But it is final, okay? So 186,000 miles per second. Multiply that by 60. Now you're probably more than 10 million miles in a minute. Multiply that by 60, and now you're more than 600 million miles in an hour. Okay, multiply that by 24, and you're getting huge numbers, you know. That's how many miles in a day. And then multiply that by 365, or 365 and a quarter, or something around there. Now the number is astronomically large, and that's how far light travels in 1 year. So we measure stars and most of the other things in light years. And so this would be 9.5 times 10 to the 12th kilometers. And doing this in meters and miles, multiply that by 0.6, and that would still be about 6.0 or somewhere around in there times 10 to the 12th miles. So that would be 6, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0 miles. That's a lot of miles. It's a long, long way for 1 light year. So where would the nearest star be? Hundreds, if not thousands, of light years away. How about distance across our galaxy? 100,000 light years. Okay, so multiply all that by bunches of more zeros. So these stars are way, way out there, except for our sun. Our sun is 93 million miles away, which would be a small fraction of a light year. So, huge distances. Okay. Now, that's not all you see when you look out there at the night sky. You see these other things called planets. Now, I can't just look out there and say, oh, that's a star, that's a planet. Not with my naked eye. I can't do that. What I typically do, though, is look out there early in the evening or late in the morning, before the sun comes up, not too long. And then usually the brightest things you see, except for the moon. You see this other thing out there, the moon, and it may be full or just a fraction of the moon or whatever. That's the biggest thing you see at night. And then after that, the next brightest things you see usually is going to be Venus. Okay? Especially if it's early evening or late or morning before the sun comes up. Okay, just before it comes up. And how you can tell if it's Venus, look to the east in the morning, get my directions right, east in the morning, and if you see something very bright, one of the last things you see before it's too bright to see anything, that's usually Venus. West in the evening. Why is that? Because Venus is between us and the sun, so wherever the sun is, Venus is going to be pretty close to it. So that's why Venus is often called the morning star or the evening star. It's not really a star, it's that bright thing out there that looks like a star. Usually the next brightest thing usually is Jupiter. This is after the moon, after Venus. That's also a planet. And Jupiter is further from us from the sun, but that doesn't mean it's always in the opposite direction, because it could be on the other side of the sun. That's when we see Jupiter at its brightest, because it's almost the full Jupiter. When it's nearer the sun, it's usually, if it's between us and the sun, we're seeing more of the dark side of Jupiter. So, but usually that's the next brightest thing we see. Then there's some very bright stars. So how can you tell, not with the naked eye, but if you have binoculars, a good set of binoculars or a telescope, and you see that bright thing out there, and you look at it through that, and if it doesn't remain a point of light, but now seems to be extended, you actually see a circular thing, sort of like you do the moon, only smaller, and you could see some phases of it, meaning crescent type things, then you know that's a planet. You'll never see that in a star, but you will see it there. Why? The planets are reflecting light from the sun. The stars are producing their own light. You see that point, and that's all you see. These are reflecting light from the sun, and in order to be seen, they have to be close enough, they're sort of big enough you can see that. But you can see the shape, even though it's not maybe a perfect circle. Okay? Now, if it's Jupiter, and you have a pretty good telescope, it doesn't have to be great, but a pretty good telescope, you probably, if you look carefully enough, you not only see its shape, but you may see shapes of things near it. There are 4 Galilean moons around Jupiter. Now, why do we call them Galilean? Have anything to do with the Sea of Galilee? No, why? Galileo was the first one to see it because he's the first one to develop a telescope strong enough to see it. He wasn't the first to develop a telescope. Someone else had already done that. But he improved it so much that he looked at Jupiter and saw these 4 moons, the biggest moons of Jupiter. Jupiter only had like 50 or 70 moons, something like that. But these are the 4 biggest. He could see it with a pretty simple telescope. They named them the Galilean moons because he was the first to record them. Now, what in the world is that? Anyone have any ideas? Stonehenge. And what is Stonehenge?
A bunch of rocks on top of each other.
Yeah, it's a bunch of rocks, and if they're not on top of each other, they at one time were on top of each other. And these are not mighty miniature rocks either. I think that's a person right there. Okay? These are enormous, huge. And how did they come to be there? Geological feature of the earth? No. These rocks are not even from the area. These rocks were hauled in from somewhere else. You do not find these rocks anywhere close by. They were hauled in. Massive, huge, heavy, enormous, big rocks. Who did that? We have no idea. Where are they? Where's Stonehenge? Anyone know?
Scotland.
Second? It's near Scotland. They have a lot of these things, but it's actually England, south of Scotland. I haven't seen them, but I've read about them a lot. But these rocks were hauled in. Now, when we say England, where do we get the name England? That comes from Engleland, basically. The Angles were a Germanic tribe, so they came over from Germany. They came over about the same time as the Saxons, which was another German tribe, and that's why we get the Anglo-Saxons. Stonehenge was on there way before they came. Okay, way, way before. Who was there before them? Well, there were the Picts and probably some Celts, Celtic type people. We don't even know if these predated them. This is so far back in history, we don't even know the people who did it. In fact, there wasn't any history. This is prehistoric man. We don't have any history of who did this. So this is way, way, way back there. How did they get these huge boulders here? We don't know. I mean, it would probably cost us, I would say, several hundreds of thousands, if not millions of dollars to transport this many, this heavy, this big a rock from wherever they got them from to here in today's terms. And it would take a while, okay? They did it somehow, and we have no clue, okay? Now, you can't tell from this because some of these have fallen down and other things here, but some of them you can see they have these across the top. And at one time, every pair of them had a big boulder across the top. And these things are huge. Okay, number one. How did they get these shaped in this way and the tops flat enough and even enough? That took some skill that you don't usually think of as prehistoric man skill. And then, how did they get them up there? Transported there is one thing. How did they lift them that high? Today, we'd have to bring in cranes, big, expensive cranes, and lift them up that way. I can't think of any other way to do it, but they have these standing pretty close to perpendicular, and perpendicular across the top, enough that millennia, thousands of years later, they're still standing, most of them. And this is an area that has been known to have earthquakes and things, and most of them still standing. Okay? Now again, you can't see it from this perspective, but if you were in the middle of that group of stones, and you looked at the horizon, say right as the sun was rising and setting, and if I'm not mistaken, there are 12 pairs of stones. I think there are. And if you looked at it at the time of the sunrise or sun setting, you would see that every month of the year, the sun is coming up or setting one right through the right set of stones. Okay? And not just that, certain constellations are just coming above the horizon or going away right then. So not only were these brought here, shaped, maneuvered, but they were very accurately, precisely placed to catch and basically form our first calendar, a yearly calendar. How did they do that? Okay? I mean, if I got that stone in place and even shaped and stuff and level and flat, to get it placed perfectly so that at the center you can observe all the stuff happening around the year. And why? I mean, maybe rituals, sacrifices, I don't know. Or when do you plant your corn? When do you plant your grain? When do you do this, that, or the other thing? That was probably their calendar. They didn't have calendars except for that. How in the world did they know this much and have this kind of knowledge, skills, and ability to put that in place? Don't discount these ancients. They had to be some pretty sharp people. Okay? Pretty amazing. Okay. So, what did these ancients see when they looked up in the sky? Well, they saw these brilliant display of stars. Okay? What it appeared to be that there was some, what they call this, I call it a hemisphere, they call it a sphere, celestial sphere. Someone put a bowl on top of them with all these stars in place. And maybe the ball was spinning a little bit because they could see it moved. And it moved differently in different times of the year, but it was moving. So this is what they classified or called the celestial sphere. As they look up and saw, they seem to be in place, out of reach, but up there somewhere. Okay? Now what you can sort of do is imagine that you had a light, a single point of light sitting right in the center of the globe, and you didn't have anything to block its view, and you turned on the light, and there it was. This display, only it had little holes in it. So let's imagine that where the stars were little pieces of aluminum or silver thing, little mirrors that showed where they were. A little bit better to imagine that the light was shining from there and poking through there. However you want to imagine, the celestial objects are projected onto that imaginary sphere that surrounds the Earth. Okay? Now, because of that, if you picture the light being right in the center of the globe here, and the projection moving out, but the couple of things that didn't allow the light through was the equator. And it's projected out there. Well, then there is called the celestial equator. Okay? Now, they mentioned that first. I think I would have mentioned right there. The light going through the very northernmost part, that's the North Star. Always sitting right there, not moving. Okay? That's due north. Now, you can imagine that there was another where this South Pole is, that you could imagine there was another one down there. Now, we'll never see it in the northern hemisphere, or we won't see that. But what's more, there's no star there. Right around where our South Pole should be is a big empty space. There's no stars in it. So there's not a South Polar star. It just happens to be this little star. It's not a very major star. It just happens to be sitting right about there. And that's our North Star. But you can imagine that there was a North and a South Pole there, whether there's a star there or not. And then the equator is exactly halfway. And by the way, that's what equator means. Equal distance between the North and South Poles. Equator. Equal. Okay? And these align themselves with Earth's equator and the North and South Poles. So that's the visual image and what you can imagine about this celestial sphere. Now, so here's another way to look at it. We have the Earth in the center. This is one place the ancients were a little bit off. We, believe it or not even teenagers are the center of the Earth, okay? Everything doesn't revolve around, no, I'm being mad. Okay? But neither is the Earth the center of the universe. For many millennia, people thought it was. It's not. But let's just imagine you have the light in the center, and the Earth is really transparent, except that you have a hole there, a hole here, and this line around it. Project outward. There's your North Celestial Pole, South Celestial Pole, and your celestial equator. Equal distance from the two poles. Equator equal. Okay? So that's the image. And then the stars are populating that celestial sphere. Actually, the whole sphere, we only see half of it at any one time, and some of it we never see. Like this part down here. We never get to see unless you travel south of the equator. Okay. Now, if there was supposed to be another picture there, and I can't tell whether there was or not, it didn't show up on the PowerPoint. So let's move on to this. Here's a picture we saw at the very beginning that was shown here. There is this camera pointing due north, and I don't know what this is, except something to hold the camera in place. I don't know. But anyway, and the aperture is open all night long, and you see the paths of the stars turning around that North Star. Now, there are a couple things. First place, If the Earth was flat, you would need, say, a horizontal line, a vertical line, and where they cross, you say that's the origin, and you can measure things right or left, up or down from that point. That's what we do on a Cartesian coordinate system. Good old math, right? Applying things. We don't live on a flat Earth, no matter what some people say. We live on close to a sphere. It's not exactly a sphere, but pretty close to it. So how do we identify where we are? We don't have left or right or anything, north or south of anything, east or west of anything. Well, we sort of do. Second?
The numbers all line up.
Okay, and what do those represent? Second? Yeah, I know, but what do the numbers, those numbers you were mentioning? Second?
Oh, sorry. I was saying the latitude and longitude.
Absolutely, okay. What do we mean by latitude?
Lateral.
Okay. Let's start back with our north and south poles, okay? And then we have that equal line in between. So let's do latitude first. That celestial equator here is on the celestial sphere up there, corresponding to this one. How many degrees, if you had a protractor at the center of the Earth, right there at the center, and how many degrees north or south of that equator you would have, that's your latitude. So they go, and look at this one, 15 degrees, 30 degrees, 45 degrees, 60 degrees, 75 degrees, 90 degrees. From the equator to the North Pole, equator to the South Pole, 0 to 90 degrees. So those define how far above or below the equator you are. That's how we define things, at least in one dimension, on a sphere. Now, you also said longitude, right? Longitude is a little tougher, okay? Now, latitude, there's one, what we call a great circle, and that is the equator. Everything else is smaller than that, going either direction. But for east-west stuff, we draw a circle through the north and south pole, exactly through it all. So all these are great circles, as big as you can get around here. They all find the maximum diameter of the Earth, that great circle. Okay? You draw a bunch of those around here. And then, because good old England, the sun never set on the English Empire, remember that? England was a great naval power after they defeated the Spanish Armada. Nobody could touch the English Navy, British Navy. They controlled the seas. Britannica, the Queen of the Ocean, something like that, that was Britain, where their naval observatory happens to be a little bit, they don't show it on here. Shame on them. A little bit east, not too much, just a little bit east of London. In fact, my wife had professional meetings, I believe in Paris sometime or another. She's a scientist at UAB, and she gets to travel internationally almost every year. And they had meetings in Paris, and so she asked her niece if she wanted to go, and she said yes. And when she heard that, her other niece wanted to go, and then her mother wanted to go, and then one of her niece's mothers, Karen's sister, wanted to go. So suddenly she was being a tour guide, and she didn't have time for her meetings anyway, and she was going to have to pay for them. So she wound up not attending the meeting, but planning the trip for the gals in her family, two nieces, her mother, and her sister. And I can't remember where they started, where they went, but ultimately, I think all but two of them were wound up in London. That may be where they started. The other two were coming in later. And one day trip they took from London was to Greenwich, England, where the Naval Observatory was. Yes. Now, they didn't really see much about that, but they were opening a new building, or christening, or whatever, a new building. And because it's the Royal Naval Observatory, Queen So they got to see the Queen when they were there. They were just at the Naval Observatory in Greenwich, England. But that's where they chose to put the 0 meridian line, or actually the main meridian line, which really means 1, but it really isn't 1, it's 0, the prime meridian, or Greenwich meridian, because it went through Greenwich, England. And that goes all the way down through, from the North Pole down through Greenwich, England, to the South Pole, and then it comes back up the other side, but it's not called the prime meridian there. It's given by a different name. Okay? Now, that gives them the reference point, and anything east of that is so many degrees. And you see your meridian lines here. There's your 0, the prime meridian. Going east is 15 degrees east, 30 east, 45 east, 60 east, 75 east, 90 east. Keep on going, 105 east, 120 east, 135 east, 150 east, 165 east, until finally you get over here at 180 degrees east, which is exactly opposite your prime meridian. This is given the name the International Dateline. Okay? Now why is that? Because if you imagine the Earth's always spinning, I'm spinning the right way, always spinning. So at some time it's noon in England, but it's early morning over here. Very early morning. Okay? And it's even earlier here. Well, back here it's very, very, very early, but over here is very, very late, because they're ahead of it. Okay? Well, on that international dateline, on one side of the line is one day, on the other side the other. At the same time, but 2 different days. You cross the line and you go up a day or back a day. Okay? Now, there's a weird story with that. I'll wait till we talk about that in class to give you the weird story. The naval story that has to be weird. But anyway, that's what we measure east-west from that prime meridian. Okay? So north-south is from the equator from 0 to 90 north, 0 to 90 south, and east-west from 0 to 180 east, or 0 to 180 west. That's how we identify every position, like we're saying, on the globe. We don't have XY lines, we have latitude, longitude lines. Okay? So, that's how we determine the location on the celestial sphere. Except, we can't look up there and see, oh, there's the prime meridian, here we go. No, they don't have things like this. All you have when you look at this celestial sphere, you see where you are. Okay? And where you are is your celestial meridian. So if you can pick up that North Star and go straight north of there, directly overhead, by the way, directly overhead is called your zenith, and then go to due south, you don't ever get to where the South Pole would be, but due south, that is your celestial meridian. Okay? And that celestial meridian is how far east or west you are from the prime meridian. Or, you're looking at the star up there and say, oh, I see a star here. Well, that's so many degrees east, so many degrees north of your horizon, so many degrees east of your celestial meridian. So the celestial meridian is your east-west location of you, the observer, okay? And objects appear to rotate about the north-south poles. So in other words, if you're looking at a star near the North Pole, at some time of the night, it's probably here, later it'll be there, later it'll be there. It seems to rotate around the North Star. Over here, don't realize that's what it's doing, but you see it move overhead overnight. It'll start in the east and wind up in the west. Okay? And these over here will do the same thing, only they're moving smaller circles. Okay? So, objects appear to rotate around that north-south axis. Why? Because we're spinning. They're not moving, we're spinning, so our perspective of them. You see, let's start with us. Early morning, we see a star here. It turns, and that star appears to be moving that way. Okay? And sure enough, that's what it is. It's fixed. We're the ones moving. Okay. And that's what these light circles are around the North Star. All right, so let's get a couple of these angles in play here. The altitude angle, well, first, what are we measuring from? You're placing yourself in the center. Directly overhead is the zenith. I mentioned that. They don't show it here. This is our horizon, okay? So I'm right here, and my horizon is everything that's horizontal as low as it can go. So I look, goodness, all these trees, it's hard to see something that's right on the horizon. But that's what our horizon is. Horizontal, flat line, all the way around. Okay, our altitude angle is how far above that. So let's say there's the star I'm looking at, that thing coming out of there. So I go from horizontal, measure up the angle, go up from there. Whatever that angle is there, that's the altitude angle. Azimuth angle, okay, that's a little bit stranger. We go to due south and measure either east or west from due south. So if that's my star there, and there's due south, then I measure along the horizon how the angle between here and there. Now that looks to be, this would be 90, so that would be maybe 120 degrees west of the South Pole, okay, of due south. This one shows 45 degrees east. So that would be 45 east would be right about there, and it showed 30 north right about there. So there's the star they were looking at. Now this is our celestial meridian, not the one through Greenwich, England. This is ours. We're 90 degrees directly overhead. This is here, you know, like that. Okay. Now, except for this place in the book, you're not going to run into this again. When we get to the lab and do something like this, we're going to use different ways to measure north, south, east, west, but it'll all be pretty transparent. Okay? If there was another one to put here, they sure aren't showing it. All right. Let me just mention a few other features in your book when you do get your book, however you go about getting it. Every now and then they'll have what they call a science sketch. And I don't know, the one they show on page 355 I don't see as all that useful, but if you wanted to try it, you could. And almost the same colors as those science sketches, they have something called concepts applied. And this is one that's pretty interesting, so I think it's worth our time to do this one. It probably falls under the next section, stars, which I've got on the screen now, but it's also just observing. Okay? Now, I don't know what your experience is with observing things in the sky. Those people who know what they're looking at, and say, oh, there's the big bear, there's a little bear, there's a Orion, there's Perseus, there's the flying horse, I can't remember what that was called. You know, there's all these shapes out there. I look up, I don't see them at all. Orion comes the closest. I can pick out Orion because I see his belt and I see his sword and I see sort of his shoulders and things. That's about it. That's about the only one I can pick out and say, I know what that is. Now, there is something else out there that I can pick out that's even easier than Orion. But it's not a constellation. What is it? Anyone know? It's a group of only 7 stars, I think. The Big Dipper. Big Dipper.
That's not a constellation.
No, it's part of the constellation Ursa Major, which is the Big Bear. And then there's also a Little Bear. I can't see a bear in any of those. Second? And the Little Dipper is in the Little Bear. Okay. Yeah. Now, you can pick out that Big Dipper because it really looks like a Big Dipper. And bright stars, I think there's 3 in the handle and 4 in the cup. Okay? And the handle is shaped great and the cup is shaped great. Now, those last 2 in the cup, wherever you find that Big Dipper, it's usually really easy to find if it's up. Some of the time it's below the horizon, you can't see it. But when it's up, it's easy to pick out. Find those last two, the handles over here, the other cups, these last two here, these are called the pointer stars. Point in the direction from the bottom of the cup to the top of the cup, and point, just let your eye follow a line across there. You'll run into a little star that hits. That's the North Star. Not nearly as bright as any of those in the Big Dipper itself, but it is a star, and that's it. Now, I've seldom been able to pick out the Little Dipper. Problem with the Little Dipper, the handle curves the wrong way. You know, it is look like a dipper, but the stars aren't nearly as bright as the Big Dipper. But you can kind of say, yeah, that looks like it might be a dipper there. Okay, but the end star of the Little Dipper is the North Star. Okay, and that's what the concepts applied here is showing. Okay, and by the way, the North Star, what we call the North Star, most of the time is called Polaris, which means the pole star. Okay, but you have to remember it's the north. Okay, then there's another feature in the book, and this guy is really sort of big on this one: myths, mistakes, and misunderstandings. And I had actually heard this one before and thought it was true, and he says, no, it's absolutely not. The concept is, you look out, okay, how many stars are out there in the sky right now? If you can look through the leaves up into the sky, how many stars? Second? Billions. How many can you see? Not a one of them. If you look straight at the sun, you see one star, and that's all you see, okay? But we're not looking at the sun, and it's not a good idea to look at the sun, ever, okay? But look out there, there are billions of stars right there. If my finger we cover a billion stars right there, easily, okay? But you can't see them because of the light from the sun. It blanches out. It swamps the other light coming from the stars. Now, the thing that I heard, if you had a long enough tube, like a tube that a roll of paper towels came on, but it was much longer, and you could block out all that sun, that you could actually see those stars. Or the other direction of that, if you look down a well, even as long as the sun wasn't directly overhead, you would be able to see that. Those are both myths, not true. And they explain that here. It's not the light coming through like that from the sun. It's just you can't do it. It's not there. Okay? And that was a myth that I actually had heard in my youth and found out when I read this book, it's a myth. I'd never seen it, but I thought if you had one long enough, yeah, you could. No, not really. Okay. Or if you could, it would have to be long enough to go all the way through our atmosphere, get out into space, and they don't make toilet tissue rolls that long. Okay, never mind. Or paper towel rolls. Okay. So let's consider what the stars are. We already get they're point sources of light out there by themselves, that kind of stuff. So what are they really? Incredibly massive, dense. Now what does massive mean? Say again? Okay. Big in the sense of weight. Massive means weight. It doesn't mean weight, it's related to weight. So very massive, very dense. What does dense mean?
Compact.
Yes, everything's packed into something pretty small. Now when I say pretty small, it's huge, but they're very massive, very dense balls of incandescent. What does incandescent mean?
Right.
Giving off its own light. An incandescent light bulb is one that's shining. Okay,
What's the
it's
difference
giving off.
between incandescent and iridescent?
And what?
And iridescent? Iridescent?
Iridescent. Incandescent, and this is just a guess. Incandescent is something giving off because there's a lot of energy. Iridescent, I think, is often reflected, but off different kinds of surfaces that make the light seem to change and stuff. Like I think of the fish scale as being iridescent, and that it seems bluish or pinkish or something. Yeah, but this is incandescent, meaning it's giving off its own light. And what's a gas? A state or phase of matter. And which one is that? The heaviest, the lightest, the middle, lightest by a long shot. So something doesn't seem quite right here. There actually is one thing that's not quite right, but that's a picky point. You don't usually think of gas as being massive, nor do you usually think of it as being dense. But this is a gas, meaning the individual molecules or atoms are not connected to any of the others by any way except, and I'll give you this now, gravitationally. Okay? And that's what makes it so massive. You've got so many of these atoms or molecules and stuff, usually atoms, and they're bound gravitationally, so they're so close together it makes them very dense. And by the way, in physics and geometry, the way to get the most mass inside the smallest volume is a sphere. So that's what makes it a ball of incandescent gas. And why are they incandescent? Well, number one, there's so many of them packed so tightly together that they, when you rub your hands together and push them greatly, what do you notice? It warms up. They get very hot. That's because of friction. And even though these are gas atoms, possibly molecules, but usually atoms, they're bumping into each other with such regularity that they're producing a lot of friction. Well, that friction can only get so hot that it may glow a little bit, but not enough for us to see that far away. What happens is those massive balls, dense balls of gases have so much friction that the temperature goes so high, so incredibly high, that, and by the way, those atoms are hydrogen. Now, I keep flipping flopping whether I want to call it atom or a molecule. Actually, a molecule of hydrogen, H2, an individual atom would just be H. I think these are molecules, so there are two of them, but they are, gravity is pulling them so close together, and that makes them so hot, so incredibly hot, so powerfully hot, that they get up to a temperature that starts fusion reactions. Now, what do we mean by fusion reactions? You're forcing two or more objects together, fusing them together to making a new material. Not just a new phase of the same material, a brand new material. You're fusing hydrogen to make helium. Okay? That is not a chemical reaction, it's a nuclear reaction. Now, what's the closest thing we got to that on Earth? Nuclear reactors. A nuclear reactor. Is that a fusion reaction? No, that's a fission reaction. Okay? Now, what a fission reaction is when you have these huge, massive atoms, like atomic weights of 190, 192, huge atoms that you make, or they're already unstable, meaning they're radioactive, they're giving off particles, and if you bring those in close proximity to each other and fire some extra neutrons in there, you get them out of balance, and these huge atoms break into smaller atoms. That's fission, breaking apart. And these give off incredible amounts of energy. Okay? Nagasaki, Hiroshima, nuclear power plants, Fukushima, Chernobyl, 3 Mile Island, in my home county, Vogel, I'm sure here in Alabama there's several. And nuclear submarines and things like this. Enormous amounts of energy coming out of those fission reactions. Enough to destroy 100,000 people in one explosion. Enormous amount of energy. That's nowhere close to what's happening in the fusion reaction. In fact, you have to have some number of fission reactions. The nuclear bombs that we've tested, and several other countries have too, to get enough energy, they have to have a series of, I think it's 3 or 4 fission reactions going on around them to get enough to force the hydrogen and helium together to produce fusion reactions. So it's a really hot process. These fusion reactions are happening in the core of these massive dense balls of incandescent gas. What makes it a gas? Why don't they collide and become a liquid or a solid? Because they're so stinking hot, they can't exist in those phases. Okay. So, our sun, as we said before, is just an average old star. Nothing spectacular about it. Biggest one we see, but why is that? It's the closest. 93 million miles as opposed to tens or hundreds or thousands of light years, which are way bigger, way further away. But we use the sun as our reference for understanding the other stars. And that's what makes it good that it's an average star, because you have some bigger, hotter, all these things, and smaller, cooler. Okay. You have some bigger, cooler, and some, yeah, whatever. Okay. So what's the origin of those stars? Remember that picture at the front of your book? That nebula, that mass of gases that just seems to be floating around out there, mostly hydrogen gas, just floating around out there, but massive, I mean, incredibly massive, okay? Meaning very big, and this is in every sense big. Something happens. Maybe there's an explosion somewhere else in space, like maybe a star near the end of its life has a nova or supernova happen, and you have this shock wave that comes across vast quantities of space, and that shock wave happens to push some of these atoms of gases or molecules of gas closer to others. You know, that's what happens in a shock. That's what's happening when I'm talking. Okay? If you held your hand in front of your mouth when you're speaking, you'll feel a little burst of air that condenses and rarefies, condenses and rarefies. Well, that shock wave that comes through space is condensing those close to each other. But what happens then, they condense close to each other, and now the gravitational attraction between them, which when they were out here, 10 times further apart than they were here, well, gravitational attraction falls off by the square of the distance, inversely proportional to the square of the inverse square law. So if they're 10 times further apart, they're 100 times less force. So they don't notice each other then. When they get this close together, now they're 100 times more likely to be attracted to each other. Okay? And with that extra force, this induces what we call gravitational collapse. So these molecules collapse on each other. They're pulled together by gravity. Well, guess what? Now they have more mass. They're pulling more in and more in. And soon they're pulling lots of this massive thing of gases to smaller and smaller spheres. Okay? And they keep doing it and keep doing it. That's what we call gravitational collapse. Because what was a massive quantity here, same number of molecules, but now are pulled into a very small sphere, and it gets smaller and smaller, and it heats up. So the gravitational energy is released into higher temperatures, but also higher pressure. Now, what is pressure? Does anyone know the definition for that? See, part of this is why the physical science books have the physics and chemistry in the first part, so you'll understand these terms. The way we teach it, it's in the second part, so they haven't defined these terms. What do we mean by pressure? It's a simple little definition for pressure.
A lot of stuff built up.
Say again?
A lot of stuff built up.
One more
A lot of stuff that's built up.
Okay. It's stuff that's built up. I'm going to give you a really dumb example. I was dancing with my darling, okay, right? And she has on sneakers. And she happens to step on my toe. Not too bad. Or, dancing with my darling, and she has on spiked heels. And she steps on my toe. My darling hasn't changed it. She's the same mass, same weight, same everything, except which do I feel the spike heel. Why? Because you have more pressure, which is weight per unit area. And the spike heel has a very small area, same weight, okay, but a very small area, the pressure is huge, okay? Whereas sneakers, bigger area, the pressure falls off a lot. So that's what pressure is, force per unit area, okay? So you have the same weight of mass that you had out here, this huge, huge cloud. Now it's in this tiny little sphere, but the force per unit area is much, much greater, okay? So both higher temperatures and higher pressures, okay? Now, what started as a gaseous nebula, this shock wave comes and starts condensing. That could happen, but unless you get to a certain stage, it may just go back to being a nebula, okay? They, after a while, fall apart, whatever. But if it becomes a protostar, and what the protostar is, the accumulation of these gases that will become a star. You get to the point where the temperature gets high enough that you get fusion occurring. And when that passes that phase, you're going to become a star. Okay? So go to the next slide. Don't have much more time. Now, y'all have to sort of watch out for time. I get carried away sometimes. So if it ever gets to be 3:30 and I'm still talking, stop me, okay? The reason I say that, it's not that I don't want to, give you extra information for the same dollar. It's that I've got to be at the Birmingham campus in 30 minutes, and it takes me almost that long to get there. So stop me, okay? So what happens when it becomes a protostar? Now you get to enough of a mass of the gases, hot enough that fusion actually occurs, okay? Now, they're sort of jumping over to becoming a full-fledged star. Here's what happens after that occurs. You have the core, and we've already mentioned the core before on the last slide, and here's the big news about the core. The fusion reactions occur in the core. That's the only place the fusion reactions occur. It's the only place hot enough for the fusion reaction to occur. So you have the core very hot. The most dense region, that's where you got all that heat, that's where the nuclear fusion releases. And when it happens, remember the pictures of the atomic bombs? You see expansion occur, big time. And this releases gamma and X-ray radiation. Now, what is gamma and X-ray radiation? Deadly radiation. Gamma radiation is deadly. Wait a minute, our sun's out there producing gamma radiation. Why aren't we toast? Say again? Our atmosphere. Our atmosphere forms a blanket around us, and part of the features of that atmosphere, it reflects basically almost all of that gamma radiation. The vast, vast majority doesn't penetrate our Earth's atmosphere. Okay? Nor do the X-rays. Wait a minute, X-rays aren't damaging or deadly, are they? You better believe they are. Now, in small enough dosage, not that harmful, okay? But if you ever notice, have you ever had an X-ray? Either of your mouth or of a foot or leg or anything, you haven't had an X-ray. What do those technicians do?
They cover you with the.
They what?
They cover most of you with some sort of blanket.
Right. Okay. And where did they go?
Away.
Away! Inside a little room with very dark glass. They can see out with very dark glass. And you know what's in the wall of that room? You don't see it. Lead. One of the densest metals we have. And in that glass, it's leaded glass. They're back there protected as much as possible. Because they're doing this all the time. The X-ray, that's about it. They get the picture of whatever they're looking at, your teeth, your bones, whatever it is. They see the picture, that's enough. That's all you get. They're in there all day long. They're not out in that room all day long. They're behind leaded walls, and they're wearing a badge. And that badge is probably a photographic material that gets darker when it's exposed to more radiation. And every month they turn in that badge and they measure how much they were exposed to. If they exceeded the minimum that's safe for them, they probably have to have a few days off, maybe a few weeks off, or something like that. They're very careful. They don't get paid if they're off for that. Very careful not to get exposed, because X-rays are deadly, damaging. They destroy tissue. That's why they go right through flesh. They get bounced off the bone or the teeth, but they go right through the flesh. And as they're passing through, they're probably leaving little tracks of damage. But if it's just, and that's it, it repairs itself. If they're all day long in there, they can't repair themselves fast enough. They could get cancers or other things like that. So that's what's being produced, and we've run out of time just as we make it into the core. Okay, so let's see where we go from here. Oh man, where we'll start next time is example 4.1. And I've got to find where the radiation zone. Okay, so we'll do example 4.1. I skipped over that. I didn't mean to, but I did. And then we'll go there. And by the way, there is a picture there of the Orion Nebula, birthplace of an enormous number of stars ranging in size from scorchingly hot blue stars, we'll talk about that later, to tiny dim brown dwarfs. Many of the stars are hidden in the dense nest of dust and clouds, blah, blah, blah. Beautiful picture there. Taken by, I think, the Hubble Space Telescope. I'm not sure, but I bet so. All right, and we'll pick up there next time. Good deal. Looks like it's going to be a good class. Appreciate your being here. Oh, and Ed didn't make it back, so let me mark him absent. Okay, good deal. I'll let you know whether, if you don't hear from me, be here at 12 on Tuesday. If you do hear from me, I'll say 12:30 or 12:45 or something like that. You can be here at 12 if you want to, but I just won't to.
Have a good one.
Good. You too. Thanks.